All right, what is going on, ladies and gentlemen? We are live. Welcome to the Two Savage for Democrats podcast, episode 104. Is the Earth flat? That is the golden question for today's podcast. Why don't we let our guests introduce themselves, kind of talk about where they stand and what they believe, and then we'll get into the bulk of the debate here.
Hello, my name is Josh Corey. I'm with Iron Realm Media. You can find us on Iron Realm Media on YouTube. I found the flat Earth at the end of 2014, was probably convinced by the New Year's. So by 2015 hit, I'd say I was on board as much as I can be.
Yeah.
Okay.
All right, what about your buddy there? Oh, he's muted. Oh, there he is. All right.
Hey, what's up, everybody? I'm James, another member of the Iron Realm. And I came to Flat Earth, I think it was the end of 2014, I'd say. It kind of was like a realization that all roads were kind of leading somewhere. And it's been great. I mean, it's an exciting thing, and it hasn't gone away. So it's exciting that we get to discuss it today.
I am very much looking forward to this. So why don't we, and of course we have Brian, as usual, guest,
Brian.
Usual host of the show, actually. Brian's a host. So this is a really interesting conspiracy because this is something that obviously a lot of people believed a long time ago, you know, and then it kind of changed over and not many people believed it. And recently, within the past 5 years or so, there's been like a reemergence, like a big reemergence of the flat Earth. Now, there might have been some before that, but within the past 5 to 8 years with the rise of social media, I think you've seen a lot more people come out and embrace this. What convinced you guys to come over to the side of the flat Earth? Right. I'm just trying to open it up with some questions, and then, you know, we can obviously bounce these off each other and get into discussions on. But I want to know really, what was it that convinced you guys, hey, this thing is flat and you can't convince me otherwise? What was it for you guys?
Well, for me, I don't know that I couldn't be convinced otherwise. I mean, I will leave open for the option that it's a ball, but it would have to be considerably larger than we've been taught.
Well, it's actually an oblate spheroid is the actual shape of the Earth, because there's a bulge in the center of it around the equator.
It's a little chubby.
Yeah.
A little fatter on the bottom.
Well, in the middle, not at the bottom, in the middle.
Well, even on the bottom, it's a little fatter by about the size of
the shape of the oblate spheroid. Yeah, but yeah.
It's not a perfectly oblate, fatter on bottom than it is on top. It's like pear-shaped is what Neil deGrasse called it.
Yeah. So why don't you go? What convinced you originally that it's flat? I mean, what evidence led you to that? What things were you seeing and you were saying, hey, this can't be round? You know, all the other planets are, but our planet isn't. What led you to believe that?
Well, I would say that I don't know what shape the world is. The azimuthal equidistant projection does definitely show the South Pole as a ring of ice around us in a circular form. The exact shape, I don't know.
Can I ask something?
Absolutely.
Why was Earth kind of in the random chaos of the universe? Why was Earth kind of the only planet that became flat? Like every other planet, why is Earth the one exception?
I would say humans.
Humans made it flat?
I would say humans are the exception. How many other planets do you see out there that have human life?
Well, they probably had life.
Well, you can't really answer that question right now. That's like, just like you were saying before, we don't know the exact shape. We also don't know that there's not other life out there, right?
Yeah, and I think Drake's equation kind of showed evidence that there likely is life everywhere. We've had evidence on Mars of potential microbes that used to be on Mars. Venus could have had life. They had an environment perfect for it.
Before the
there's always rumor of a good chance that they've been really close for like 50-60 years. It's cool. I mean, I feel we're close to something.
Just because like Earth happens to have humans on it, though, how does that affect the shape of the planet? Like, why does that impact it?
Why does it make it special? Why does it make it different than all the other things that we see in the sky?
Why does it make it this?
Why is it that every other planet in the solar system every other known planet is not flat, yet Earth is? I mean, we can watch the other planets. We could see Neptune. We could
first we have to ask though, what do we really know about other planets? Seriously.
Well, we
We-
can
We know it's
observe them.
significant.
Yeah, we
Wow.
can subnerve them. We can observe them, subnerve them. I don't even know what I'm saying.
Right,
We can observe them. We know that we're looking at different sides.
Have you
because-
guys seen the images of planets through the cameras, the P900s? It's
Yes.
so cool because I mean, I grew up like being shown, Saturn has a ring around it, Mars is red, basic. And then all of a sudden I seen a video of a photographer who was just like regular guy. I don't even think he's a flat earther, if you want to call him that. And he started showing like pictures of Mars and Venus through it. And it's amazing. They look like these electrical balls of energy. They look like almost solar lumen. It's
I
really
think-
fascinating.
let me
I
ask
think
you
the
this
key
really
word
quick.
though is ball. They do look like a ball.
Yeah.
That's kind of where we're getting
Some
at.
of them. Some
let-
of them.
Let me ask you this really quick. So you don't believe in gravity, right?
Because gravity would make it a sphere.
So
naturally.
essentially gravity, well, not even that, but gravity pulls everything toward the center of the earth, right? So that's why you weigh the same in, Los Angeles as you do in China. It pulls everything toward the center of the earth. Now, if there were no such thing as gravity, those on the edge of the disc would be pulled relatively sideways, while those at the center would be pulled straight down, and the difference would change your weight enough to confuse like a bathroom scale. So there would be a huge difference in gravity depending upon where you were on the earth. So how do you explain that phenomenon? Why does everybody weigh the same? Why is there no difference in gravity?
I think
weight?
that density and buoyancy do a really comparatively good job at kind of explaining those things, to be honest.
I think there's a bit of an
Well,
issue.
can you
with that
answer that?
theory.
Wait, can you explain how? I mean, you can't just say like, oh, that that does a good job of explaining it, not really go into detail.
If you have something that's heavier than the air, what would you expect it to do? You would expect it to fall, and if you have something lighter than the air, you would expect it to rise. So those are observable. Those are observable things that are an example of how density
really that
and
depends on
buoyancy
what's in the air, right? I think like you can't just say the air. Like there's things in the air. There's the chemicals that make up the air. You can't just say, oh well, the air. It's just.
I think he's talking about relative density, though. So I guess air is really irrelevant. It's the medium around it. So one medium is denser than the other medium.
Would you say that, I'm just going to call it gravity for the purpose of this discussion. Would you say gravity is objective on Earth?
See, that's the thing. I don't know much of gravity, and I think it would do a great deal to a lot of the people who maybe believe in the flat Earth. And I'm not saying the flat Earth in general, saying you're a flat earther is so reductive and limiting and kind of racist, right? Well, not racist, but kind of, really limiting. So if you can explain gravity in a sort of a way there that we could maybe reproduce it at home, or you could explain it in an easier way, I could maybe get what you're saying.
I might have something you could do if you're interested.
Okay.
So first off, you would need something like a blanket or a towel or some sort of fabric, and you would want it spaced out, and you would want to get some sort of circular object, and you'd want to insert it on the table that's like stretched out above the ground. What you'll see is it'll kind of create a crease, if you will, and that crease is more or less what gravity is. It gets caught in the rotation.
Gravity is just the word we give to that force. It's you can say you don't believe in gravity, but you're essentially just not believing in what we call it. Either way, there's the force that does exactly what he's saying right there.
So
this was proven with Einstein's
what
theory
exactly
of relativity.
what exactly is gravity?
It's basically
gravity. Go ahead.
I was basically going to say it's going to depend on the mass of the object. If you took a bowling ball or something very heavy and put it in, what's going to happen? It's going to rip a hole in it. And when we see this phenomenon, it's known as a black hole, because you have a very large star that basically collapses on itself. So that the theory of how we know black holes kind of fits in perfectly with this notion. So if you have something smaller,
but sorry, what is gravity though? You said it depends on other objects' mass, but if you actually break it down, what is it?
Force. Gravity is essentially
gravity is essentially
like
what happens when
crease.
safe itself is curved or wrapped around a mass, such as a star or something of that nature.
So
You
it's
can't
an
think of-
it's an influence.
It's
Is gravity like
essentially-
an
You can't really think of space as like a solid desk or something. You have to think of it more as a fabric.
it's a
something-
what is a fabric.
Yeah.
Einstein's theory of relativity has been proven. It is a fabric.
How is it?
So we would.
It's been proven. Einstein's
how
theory of
by
relativity.
who?
Did you not hear the announcement? I mean, it's essentially been proven.
No, I missed that announcement.
I'm,
I mean, I
I totally missed it too. That's why I'm asking about gravity.
announcement. I've heard people say that. I've just not ever seen anything.
Let me pull up the article from 2014. You guys are probably busy focusing on the flat Earth.
And flat earthers think that things fall down, right? Things go down on a flat Earth. We don't argue the fact of the effect of something falls when we drop it.
I think the problem is though, if you try to put that as gravity, to put, for lack of a better word, very strongly have evidence to support, it kind of falls apart, because if you were to have gravity into play, which the evidence suggests, it naturally will make an object in space spherical. You're not going to find a natural.
So okay, let me just go over this.
What does it make spherical on Earth? Gravity then? If it
Well,
makes
here, let me
stuff in
just.
space,
I want
or-
to
The Earth is round. That's kind of the point.
to go back to
but
this real quick.
actually on
Scientists
Earth.
detected
Okay,
gravitational waves. Scientists detected gravitational waves which send ripples through the space and time about 4 months ago, but confirmed them last week to the public. The 1,000 scientists working with the Laser Interferometer Gravitational Wave Observatory discovered the waves stretched the Earth, though it was a mere thousandth of a nanometer and impossible to feel. But these gravitational waves have been detected. They have been proven. I can send you guys the article. They use advanced technology to find it. This is a huge, long article, but I'll send it in the chat to you guys. But yeah, so we have been able to prove that gravitational waves exist, which is essentially what Einstein was talking about.
Not to sound dumb, but I totally didn't understand that, and I don't quite honestly think that you guys quite understood that either.
Well,
So
would you expect?
what is an isotometer, and what are they? They're shooting a laser into space to tell us about the Earth.
It's an okay. Let me
what it sounds like.
let me send you the article. Hold on.
No, you tell me. I won't understand the article. I don't care.
Well, I'm reading off of the. Well, if you don't understand the article, then what's the point of having the conversation? I mean,
Well,
You
but
have
if
to
you can't
read the-
explain what you're telling me, if you can't actually yourself explain it, what's the
well, the
point?
fact that
think
you're even
having the
asking us to
conversation-
begin with what is gravity, then why are we even getting into? I mean, if you
I
don't know
think
what
I might be-
I
gravity is,
generally want an explanation of gravity, and I
Okay.
want to understand it simply
So
the way that we, as like Josh said, as flat earthers, here's what I love about it. We are dropping the paradigms of science and what other guys did. Have you done it yourself? No, neither have I. But I'm doing stuff now that I can do myself to prove what I see and I can relate to on where I live. Not 600,000 miles away with a laser beam from some guys that you've never met, with equipment you've never seen, from books that you've probably read when you were doing your science major. This is about testable, repeatable things.
So wait a minute.
nowadays.
I didn't hear what you said just then, but I got the end of it because you were lagging. But essentially, what you're saying is, why do I believe things that other people with
Yeah.
technology do that I don't personally witness? I mean, you guys believe in the flat Earth. Have you been there every single time someone has come up with a hypothesis? I mean, it's stupid to assume that.
No. Experiments, man. Like
And
moonlight.
You can't experiment.
You can do your house right now. This is why flat Earth is taking off. Like you can take
It's
a
not
thermometer,
taking off,
do
though.
a
That's the thing. It's
controlled
like-
experiment, and you can see.
You
that
think it's
moonlight-
taking off. You think it's taking off, but it's really not. I mean, there's
If I-
not that many people that believe the Earth is flat.
what I could say
Shaq
is you'd
and
have to
Kyrie and a whole
Shaq.
bunch.
So you're really going to
They're
take
basketball
a
players.
basketball players. Let's look at the number of scientists, the number of physicists, astrophysicists that believe the Earth is flat. That
Yeah,
like
if I
literally have
could-
check in this field. Let's look at
Tell
them.
me,
Let's not look
I-
at Shaq.
If I could point.
Tell me.
something out
So
real
tell
quick.
me, what does an astrophysicist do? What's his actual day look like? Do you
Well,
know
I
who
like
asked
to-
that exact question? William Shatner, who played the scientist and a captain for
Again,
40 years.
he played. So wait a minute. He acted.
Yeah.
So his
he did.
questions mean something. Oh.
Yeah, and you know what? He asked Bill Nye. He asked Neil deGrasse Tyson. He even spoke to the guy in the chair who can't speak, and he asked all of them. Tell me,
guy in the
really,
chair that
about
can't speak?
Yeah,
Hawking?
you mean the guy in the
You mean
chair
he
who
said-
can't speak?
Stephen
You mean
Hawking,
Stephen
sorry.
Hawking?
he even asked them. He asked them all. He said, "You know what? I'm famous. I really want to know though, guys. Tell me about time and gravity." And they said, "You know what? It's all in our head." He said, "What's your day-to-day like?" They say, "Well, we think about equations, and then we
well,
send me this interview, please, because I seriously doubt that they asked Neil deGrasse Tyson what his day looked like.
You don't think that William Shatner would get to sit down
Well,
with
is
Neil
this
deGrasse Tyson?
before or after he was beating his wife? Like, I'm really not sure at what point he took time out of the day to do this.
Yeah, and I just want to point out that these guys aren't all meeting together on the weekends to have a barbecue, plotting how they're going to lie. I mean, a conspiracy on this level would require at least millions of people between scientists.
Would it though?
Yes, essentially.
Would everyone have to know, or would they just think?
Okay, well, let me give you an example. We have an equation to get to the moon. We have mathematical equations to get to the moon. Mm-hmm. We've done that. We've got to the moon, and we've shared this with other governments. They do it. They get to the moon. So if that's all fake, then that.
What is the number one thing that convinces you personally, my friend, that we went to the moon in 1960, whatever?
Here, you know what?
Tell me.
Okay,
here's the number one thing that convinced. Oh, go ahead.
Well, I've watched a lot of the conspiracy theories, and I found most of them to be just a lot of their science was very poor, so they essentially lose credibility with me. For example, they make a lot of kind of claims that I think are unfounded.
There are some dumb ones, by the way. You're right.
So I see that, and I say, I've watched a few hours of these documentaries, and I could easily refute 90% of this. I don't think this is very good in my time preference to spend my time looking at something that, at best may give me shoddy science, and really no actual useful information.
Let me ask you about. I guess we'll go on.
I think like the ultimate thing that a problem I have with a lot of conspiracy theories is the amount of people that would have to stay quiet for this to go on.
Yeah, like think about it this way. Bill Clinton got sucked off in the Oval Office and 3 people knew about it, him being one of them. They couldn't even keep that a secret. So how could they keep a secret that thousands of scientists and engineers and
That's funny you mentioned Bill Clinton though. Did you read his memoirs? Did you read
Bill? All of the let's
the
continue.
memoirs
let me continue with what I'm saying. All of these people that said these things, right? Or that helped find these equations to get to the moon, that helped us get to the moon. How could it possibly have stayed a secret? I mean, how could nobody have come out? Why would it take some 40-year-old retired guy who does a podcast to be woke?
Because you can make mathematics fit to anything. Just ask Nikola Tesla.
That's not true.
It is true.
Mathematics is not, because mathematics doesn't work if you just manipulate it the way you want it to manipulate. You can't manipulate proven mathematics.
You can kind of manipulate.
I'm not saying you can manipulate proven mathematics. That's why they're proven. I'm saying you couldn't
take equations.
A mathematic equation. You can create an equation for anything is what I'm saying. And I'm right. You can't dispute that. You can.
You can't just make an equation for anything.
Okay, I have a quadratic. Okay, I have a quadratic. How do I make that not a quadratic without applying some sort of function? I'm fascinated.
You're actually asking these tards if they could figure it out. I mean, come on.
I'm fascinated. I must have missed that. I mean, I don't know how to do that.
I tell you what.
You could be given other equations and you could add those to the graph, and et cetera. Or maybe it's not equal to 0. You have to do that first.
What about the margins of error? What about even in your
answer his question. Answer his question. Answer his question. How do you do it?
Okay, you're gonna
have the margin of error isn't necessarily even that strong of an equation when you're doing something like landing on a very large. Well, it's not very large, but it's a fairly large.
You have to hit. You have to get in. To get in 1967, they used the processing power of a toaster to get into
on
a
1969.
spot. Okay, whatever. They used a toaster to get into a.
They didn't use a toaster.
A spot.
They used a rocket ship.
Yeah.
They used a rocket ship.
So what did they use? What was the computer? What was the processing power in the computer?
You said they used a toaster, which they didn't use a toaster.
They used the processing power of a toaster to equate the fucking drop-in ratio, the size of a paper.
I flat out do not believe NASA.
You can look it up right now. Go look it up.
I don't believe it because I know for a fact they've had more computer power than that in the 60s. It would have been
go look up and see what the processing.
Okay, so anyway, can you go back to his original question? Here, ask them again, Brian.
Oh, yes.
Let's make them answer this.
Yeah, that's good. I need you to type
I
that
have
question out because mathematics, I will have an answer within 5 minutes if you want.
He can't listen to a question.
mean,
You have to type it out so he can read it 45 times.
No,
Tell you the
That's
Earth is
not
flat.
like there's no number.
Actually, I
It's
don't
not
know
like a math
quadratics, so-
question. Okay, well, quadratics on the graph. For example, parabola. Do you know what that is?
No, I actually don't.
Okay, we use that a lot in physics when you're shooting something into the air. Just think of like an upside down U, all right? That's kind of what we're looking at there, all right? So it's like an upside down U. How can I make that, and that's squared to the second power. And if you were to change that, if you were to change it to the third, the fourth, the fifth, the sixth, whatever, if you could do an absolute value, for example, you'd have a V. How do we do that without actually changing the equation? Because I don't believe you can do that.
It's a very good question. Very, very good
Fascinated.
question. I mean, it doesn't bring curvature, nor does it bring the motion of the Earth, but it's still a really good question.
Right. Well, I was just curious with his math question there. And then kind of getting back to the point of the moon is we do have equations to get to the moon. And we've been working on them for a while, and we had them and we used them. They were successful. Everyone essentially conceded that. Every government did. The Soviet Union, who hated us, conceded that we did land on the moon. And we've shared these equations with other nations who've also been able to go to the moon, who's also been able to beat gravity, and they work just fine for them. So if what you're telling me is true and that they're lying, that would imply that there's a very huge conspiracy among essentially every government around the world. All the workers, all the mathematicians, they all have to keep the secret.
There's only
See,
three.
and I can prove to you that we went to the moon. They've sent probes into space, and they've taken video footage of the area where the rover landed. You can see because there's no forces on the moon. But you see, the only thing you're going to say is, "Well, that's just you haven't seen that person. That's the government."
Well,
and there's
another
no
one you could
point
see.
in trying when every single piece of evidence you're just going to say, "Well, if you directly had a 3-minute conversation and 5 minutes of sexual intercourse with the person that made this," I mean, you can't.
There's actually one you can do because we actually do. We left a piece of material on the moon where now we can essentially shoot a laser. It hits that particular area. It comes back, and we're able to retrieve data. And you can kind of see that for yourself. So that's for example, one thing you could actually do, and many people can. It's not difficult to do. You don't have to have any sort of degree to do that. And the only way that's
and
possible
we can test that it's actually there. Yeah, we can test that it's actually there because we know the speed of light and we know how long it would take for that to get back from the moon.
You can measure all the photons from the laser that return back to Earth because
we know how long it would take. We can estimate how long it would. Do you know how we discovered Neptune?
No.
You do not know how we discovered Neptune?
No.
So essentially what we did is we knew that there was some force, gravity, right, in space that was making things act strangely in their orbit around the sun, making some of the further planets act strangely, making some asteroids in space act strangely. So we calculated.
Know this because of the equations that describe this, and this is what you extrapolated.
Okay, I get it. You're good. But anyway, hold on. So we had. We understand how long something that far away would take to orbit around the sun, right? Because we know that things orbit around the sun. So we just measured the amount of gravity at that area where we predicted that this thing would be. We measured where it would be at a certain time, and they said, look at this spot at this time, and they looked and they found Neptune using Newton's laws of gravity, using that we orbit around the sun, using that principle, which has been proven almost fact. I mean, we know it would be so hard to prove that we do not orbit around the sun.
That would be fascinating to watch.
Yeah, that would be huge. But we use Newton's laws of gravity to measure and find Neptune. We use those laws of gravity, and we've used them over and over and over again. It's every single time we've said, hey, there's something weird going on out there. We don't know if Newton's laws of gravity still apply. They have applied, and there have been some sort of explanation. Exactly.
Gravity is the most wonderful thing in the universe, isn't it?
But don't you deny it?
I don't even prescribe to gravity. It was made by a Freemason, a Jesuit Freemason.
That's the thing, is you can't. You're insulting him, but you can't. I mean, what theories have you come up with that are just earth shattering?
I don't.
Okay, if a Democrat,
nothing. You sit there, refute it. You sit there quoting Shaq. Okay.
I already told you. It's buoyancy and density, not gravity, son.
Well, hang on.
Not gravity.
It's absolutely gravity.
If a Democrat said
a magic invisible force.
It's not a magic invisible force. It's
if a Democrat came up with some sort of formula and I could objectively see if that's true, I'm not going to deny it because they're a Democrat. I'm not going to deny it if they're Muslim or whatever religion or political belief they might be. If it's right and it can be objectively proven, as gravity has.
I have 10 years
Then
of
we accept
researching the Freemasons. I have
No, you
every right.
don't. No, you
do.
don't.
You Google
You-
stuff.
Okay.
Yeah, you
You
Google
Google
stuff.
stuff.
You Google
That's the
stuff, and
extent
you
of your
no. And
research.
here's how I know you don't have 10 years of experience because the first listen, because the first source you used when we asked you about the flat Earth was fucking Shaquille O'Neal. Okay,
Because I
you'd
wanted
think that
to
you'd
bring
have.
up-
Wait, hold on.
because
Shut
I
up for a
wanted to
fucking
bring up-
second, you fat ass. You'd think you'd have better arguments than fucking Shaq. So next time you debate, bring somebody up that's better than Shaq. Thank you. Continue. Oh, he left. Okay, can't even debate. All right.
Well, I thought we had kind of established the ad hominems, and we were going to keep those to a
Well, I
minimum.
thought you guys weren't going to use Shaq as an argument and then call me an idiot. So just continue with your.
I didn't realize anybody used Shaq as an argument. You
Are
said
you?
that
That was like the first
That was
thing.
one
Well,
of the first
Shaq
ones.
said that
And
it
we
was
made
an
the point
argument.
that we made a point that they're not really scholarly arguments to cite a basketball player.
right.
That would
I
be.
think
That
the
would be.
conversation was the flat Earth was blowing up. That the flat Earth was growing. The movement was growing.
Regardless,
And you said it
That
wasn't
would be like me.
bringing up
No,
people that recently came
yeah,
out.
but your first person was Shaq. You can't be like it's growing, and if you've really done 10 years of research, say that
Most recent.
Shaq.
He's the most. We're working it backwards.
Dude, I brought up Shaq because I wanted to talk about
He's the most
Freemasonry, man.
okay, well, it doesn't really matter what they are. If it's objectively true, then that's objectively true.
Let's talk
What you
about
have to do is
curvature.
repeat
I want
Okay,
to
let's
talk about
curves.
curvature. Okay.
Yes.
What do you believe the formula for curvature is?
I've seen curves.
The curvature of the Earth.
Yes.
Do you believe it's 8 inches per mile squared?
Yeah, I would probably say so.
Okay.
I've actually seen it myself. I was flying the other weekend from Vegas to Atlanta, and we had to go about 40,000 feet.
Mhm.
And usually they say, oh, it's the windows. Well, if that was the case, then I would expect some sort of distortion, during takeoff or before we got to a certain height. There was
So you actually saw the curve?
yes.
Yes.
At 40,000 feet.
You can
Yeah.
actually see the curve. If you go to the tallest building in
You
the
can-
world, the tallest building in the world is in Dubai.
And
Yes,
2
and if
minutes.
you-
Yeah,
it-
Neil deGrasse. You read that from Google. Nice canned answer.
Well, I didn't actually read that from Google.
Where did you read it? Did you?
I read it in his
talk to him
book.
about it?
I read it in his book
Ah.
called Death by a Black Hole. Essentially, if you're sitting at the top of that, the sun sets later than if you're on the ground. Now, how could you explain that without quoting Shaq, please?
Yeah, can you also explain why I saw the curve myself and why I didn't see it before or during takeoff? Why I only saw it when I got to a certain height?
And can you also explain why we can see more when we're up higher? Can you also explain if let's just say your argument about the windows. I don't know if you guys believe that, but a lot of flat earthers say the windows are
That's
distorted.
what they told me.
If you stand on the top of Everest, you can also see the curve as well. So unless there's a giant
just
window
saying,
around the top of Everest.
I was actually that's none of the above. I was actually gonna ask you guys. You prescribe to the 8 inches per mile squared formula. How do you? How can we measure that out in our own world? How can we experiment to measure the curvature? That's where I was going with it.
I mean,
man.
there's experiment. I forgot what they're called. I can't remember his name, but he did a few of them where he had like 2 poles set up with a line
not
and then something in the middle.
Erasticene? Or is that like from?
I can't remember his name.
Yeah, Eratosthenes
And
measuring.
then another question I had, like if you
No,
look
but
across
what about the
lake-
curvature? Tell me about the curvature. Like, what can we
Okay.
do to measure it? Because I have an experiment to measure it, and nobody's finding any curvature.
Can I
at
be
all?
honest with you for a second?
I hope you have been the whole time.
Yes. I don't find your experiment to be particularly scholarly when compared to people who have doctorates. And that's
So-
and they're put into peer journals where you can, I mean, if you really want to, I can't find
Do you have
journals.
access to a ring laser to do an experiment?
Well,
over
let
a
me ask you
15-mile
this. Here's an experiment. All right.
Yeah.
This is a very easy experiment that you can do. If you have a clear view of the sunset or sunrise over the ocean, right?
I want
essentially,
curvature. We're talking.
what you yeah no
curvature. Why are we
listen
getting off
listen.
curvature?
Will you let me fucking talk? Let me fucking say the experiment before you start running your stupid mouth. Let me just say what I'm saying. If the Earth is
Sure.
round, then objects which travel away from you along the surface of the Earth will disappear from the view at a certain distance, right? You can agree with that, correct?
Like Bill Nye, the ships going over the horizon.
If the Earth is round, then objects which travel away from you along the surface of the Earth will disappear from view at a certain distance. Can you agree with that? Yes or no?
Now that would have to happen.
Yes or no?
east.
If the Earth is round,
that would-
then
listen to
objects
me.
would travel.
Listen to me.
If the
That
Earth
would-
is round,
That would have
then
to,
objects would travel away from you
listen.
along
That
the
would
slope
have
of the
to
Earth.
go both ways, north, south, east, west as well,
Okay.
wouldn't it?
Could
you agree to
if
that?
the Earth is round,
If
you're
the
clearly
Earth
not
is
understanding
round,
my.
it has to go over both ways. If it disappears
Well, I have an
north, south,
example
it has
of
to
that.
disappear.
Okay, so
east,
let me.
west.
I have an
Okay,
example
so
of
let me
it,
continue
actually.
with my experiment. So more interesting is that they disappear from the bottom up. So let's say your friend is walking over a hill, and you watch him from one side of the hill as they walk over the hill. Her feet will disappear first, then her legs and the body, blah, 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 and then moving up that way.
Perspective.
Now, this is, what do you mean perspective? If you're standing on a hill, you
would have
know
to
the
move
hill
away
is
from
not
that
flat.
position.
Exactly. And if you got higher, then you would see them move down later. Right? They would move out of sight later. If you got higher than the hill, if you got so high above the hill that
So
the hill
how
looked,
is it? So how is it on the ball though that you can? Because you're always going
I have
back.
an
You're always
example.
falling away. If you're standing on a ball as a person, your viewpoint, any move you make, you're back on the ball. You're either going sideways, away from the ball, and down.
your move. Okay, so here's the thing about the
So
ball.
how
It's
can
a
we
very
see the horizon at
it's
eye
a
level?
you could see the horizon at eye level because we do not have the power with the naked eye to see very far, right? We can't see very far. Things at a certain distance from our eye. Look, I can't
3,000.
I can't remember the exact distance, but at a certain point we lose depth perception, right? At a certain point everything looks like it's the same distance away.
It's
I forgot
different
the
for every
exact.
person.
Yeah, I forgot the exact. There's an average distance. I forgot what it was.
Is that
But
a
if you-
vanishing point?
Yes, and.
Hmm.
Well, not just the vanishing point, but there's a point at which things at different distances look the same distance away because we can't perceive that distance
And-
from where we're standing. So if you're standing on an object as big as the Earth, right, a ball as big as the Earth,
It would be
It's
like
okay?
standing on a
still a ball
basketball.
though. It's still a
You-
ball. It's still a ball.
It's a ball, but the size of the ball matters in this case, okay?
Now in science, if the size, it doesn't matter. A ball is a ball is a ball. If
Well,
a
no,
ball
that does
spins
matter.
at 1,000
No,
miles
it
an
does
hour
absolutely
and
matter.
keeps water to it, you should
It
be able
Okay,
to
well,
do it.
let me
with
ask you this.
something
Let me ask
that's
you
a
this.
small ball.
Would you
ball's
disagree
a
that
ball, a
changes
ball.
the perception? Would you disagree
What?
the size changes the perception?
It doesn't matter.
Yes, it does.
No, it absolutely does. And not
This
only
is
the
all
size
about
of the ball, but also
You
the
can-
size of
I-
the person measuring the
can just
perception.
keep zooming in to the ball,
With
to the
your
person.
eyes.
Dude,
you can
you're so
scale
dumb.
it.
We can't zoom in with our naked eye.
You're not understanding. What I'm
You
saying at
asked
all.
me for an experiment,
No.
okay?
Okay.
That we can do. I'm giving you an experiment, and you go
I have
perspective.
You're
the
telling
ball."
me about standing on top of a mountain. Okay.
No, I'm giving you an experiment. You're not letting me finish the experiment. If you let me finish the experiment, then maybe you would understand. See, this might be the problem: is that you get halfway through reading logical things or listening to people who are smarter than you, like
You're
Neil
the-
deGrasse. I'm not talking to me. I'm talking about scientists who have figured this out, right? Not me, but other people, right? And you just you fall back on your ideology, your beliefs so strongly that you refuse to listen to anybody else. You have to be open-minded about things like this. Your friend at the very beginning said he's not 100% certain that the Earth is flat, but he's not
Can I ask
willing to
something?
think that it's round until he has enough objective evidence. That's how you should be coming in. I feel like you're very close-minded about this.
I have a question.
I asked
is
you guys
it-
about curvature. and
Okay,
you-
I have a question.
my buddy has a P900. Okay,
Why
he
is
could
it-
shoot islands 34 kilometers away. How is that possible? How is it?
Well, that's not means he's accurate.
But thousands
also,
of flat
I wanted
earthers have done this with their cameras. How can we be
They
shooting
shot a
things?
gun.
No, shooting pictures of places that are hundreds, 30, 40, 50, 60 kilometers away. How is that possible on a ball?
Well, I can give you an example of how you can kind of see the curve that you're talking about earlier.
How is it possible that
I fail to
people
see
with
why it's not
P900
possible.
cameras are
I fail to see
shooting
your
things
argument.
supposed to be underneath the curve?
It's a very gradual. You understand? Like it's a very.
They are
gradual
supposed
curve.
to be under the curve. How about 40 miles of curvature they're supposed to be under? How are they getting these pictures? How are these
if I
cameras
can be
shooting
honest,
in between the
for
ground
someone
and
that
getting
had
the
no
curve?
idea what a parabola is, what you learn in high school math, I don't believe your math is very good. I would have to check out your math.
How does somebody with a P900 shoot something 30 miles
How does
away
somebody
when
that
it's
does not
supposed
have
to be underneath the
How
Earth's
does somebody
curvature?
that does not
Tell me.
have a high school math level education
Tell me.
perform
let me
these
ask you this.
calculations that have eluded mathematicians for
We
years?
don't
So
even
here-
have to
so-
debate this. The P900
here's-
solves the
Let me see
equation.
your math.
Hold on.
Text
Oh my God,
me-
no, it doesn't.
Show me your
You
math.
can't
and
just
I'll
say
tell
a
you.
camera takes a picture and that means you're the that means
Send me your
nothing.
math.
If
Send
you're
me
if
your
you're
math
Don't
and
be
I'll look
okay,
at it.
hold on, wait a minute. If your camera argument is so compelling, then why can't I use my camera argument to prove we went to the moon?
You want to talk about moon pictures? Did you see the
I'm
first
just-
picture of the moon taken in 1890? It's in better fucking detail than NASA took.
We've
when they were
never
on the
been to the
moon
moon in
shooting the Earth.
1890. We were not on the moon in 1890.
We used a camera to take
You're talking about
it from Earth,
picture.
and
You
the
don't think that's gonna be
resolution.
different?
The resolution of the picture taken in 1890 was clearer
Somebody
than the
needs to chill.
resolution that the astronauts took
Clear
on the
is
first time
relative.
to the moon. On the
Clear
first
is
time to the
relative.
moon,
You don't
the
think space is
astronauts
gonna
brought a
have
camera
that
that's
clear?
shittier, and they're gonna take a picture of Earth that you
So
can't
you're just
even
gonna bring
zoom
any
in on.
camera to the moon? You're just
You
gonna buy
would
a
think-
camera from Walmart and take it to the moon?
No,
Is that how you think it works?
you would think you would bring the fucking best camera in the world to the moon to get a picture of
It's
our
not
home
just
planet.
about quality. It's also about it
Okay,
being safe
but
and preserving
answer the
film.
question. How did
I
the
just
fucking
did.
idiot retard from 1890 get a better picture of the
You know
moon
what's funny about
I
the
doubt
idiot
he was
retard from
400,000 miles away
Because you're
when
not taking into
NASA in
consider account.
1967 took a
Okay, let me
picture
ask
of
you
the
something.
Earth, which
Let
is
me ask
4
you something.
times bigger,
Do you have
and
an
it's
iPhone?
shit.
Do you have an iPhone?
Do you?
Okay, well, it's not really relevant. I was just going to bring up a point. Anyways, the point is, if you add certain security to protect the film and the camera, you're going to sacrifice quality. I don't know why that's such a
Exactly.
difficult concept to grasp.
Let's say here's a really good example.
We weren't even
Here's
talking
hold
about
on,
the
hold on,
moon.
hold on.
Wait,
Also, I want to bring
rewind.
You brought up the moon.
Before
we're
I
not
start,
talking-
wait,
You
before
brought
I
up the
start
moon.
yelling and ruin this fucking shit, the whole thing I brought up here is how a P900 camera can shoot over 40, 50, 60 miles, things that should be hidden over the curvature.
Can you send
That's
me
it.
a link
That's all I
of
want to
that?
say.
You can't just say that. Send me a link.
Send me your math too, please. I want to check it.
Yes, I want to see the math, and I want to see a picture
Dude,
from that.
You run a podcast. You're doing Google Hangouts. I know right now you can go to YouTube and Google P900.
Why don't you
Dude,
send
show
it
me
to
your
me?
math.
Do you not have evidence right there? I mean, you've been studying for 10 years. You'd think you'd have a collection somewhere in your
I have a
computer.
guy. Yeah, sure.
Probably a
Josh,
collection of child
Josh.
porn, but I mean, like,
Oh, there you go. Now the dissonance comes. Now the name calling.
Can I
Hey,
ask you something? How come when we look
Go
across
ahead.
the Lake of Michigan and we look towards Chicago, we see the buildings are significantly lower than they would have been if it was flat?
refraction.
So you don't think any of that has to do
Seen
with
the Rob
curvature?
Skiba? You haven't seen the Rob Skiba experiment where he completely destroys that theory and
I
actually
flat out don't
proves
believe
that it is? You don't believe what?
No, because I
you
don't believe.
don't have a
that-
brain to go look at a video, or you won't
If I
objectively
didn't have a
research
brain,
it?
if I didn't have a brain, I would be a flat earther that couldn't do very basic math like you.
Your arguments are breaking apart now. Go watch Rob Skiba's
So,
video
okay.
on it.
No, you're the
He
one
does it
freaking out.
perfectly.
You're getting
okay, here,
No,
listen to this.
I'm
Let me just, okay, hold on. Let me just
Your
make a point here,
pathetic little
okay?
ideology is being torn apart.
It's
so you're
because the
getting butthurt.
P900
So, okay,
angles
listen.
argument.
Get over the
Hey,
fact
hold
that
on.
it is
Okay, so
stupid.
we're gonna forget about cameras and we're gonna get into logic here,
No,
okay?
no.
So
we should
yeah,
stick
we're gonna
to the
forget about
camera.
cameras. So
I've already
okay, a
explained your
6 foot tall
arguments.
person, okay, the horizon is a little more than 3 miles away. All right, for a 6 foot tall person. Now geometry tells us that the distance of the horizon, or the furthest point that the eye can see before the Earth curves out from beneath our view, depends simply on the height of the observer. So if you stood atop Mount Everest at 29,000 feet,
Oh, that's right.
the
You can get
horizon would be
tangents in
about
different ways.
230 miles away.
That's another
Now-
point you forgot is that tangents. There's more than one way to get them.
Exactly.
So that also refutes your argument that it was destroyed. You learned that in calculus. You guys
I don't
take
care
that, I'm
about
gonna go on a limb
So here, no, but
calculus
let
or
me go into
anything
let me
else.
course you
I
don't.
just
You
want to
think
know
let me
how
continue.
it's
Wait,
possible.
hold on. I know I'm explaining it right now.
Take a picture.
I'm explaining it right now. Just call. Okay, listen. Okay.
I love
Human
if
If
body.
you
you
here,
wanna-
I'm gonna
talking
mute him.
about eyes.
I'm gonna mute him for a second while I explain because he keeps asking how and I'm trying to explain it. Okay, so here is how. All right. Now you were talking earlier about refraction, right? Refraction bends rays of light as they pass through the atmosphere. The horizon is even further. All right. Cold weather increases the amount of atmospheric refraction. So in particularly frosty locations such as Antarctica, people can actually see for hundreds of miles. Okay. People can see very far away, depending upon the amount of refraction in the atmosphere and everything like that. You can see very far away. So that's how your camera experiment works. In certain situations, you can see further than in others. Now, we are very small in comparison to the size of the Earth, right? The Earth is very large. It's a very large ball. If I were to be standing on a workout ball in a gym, right, I'd be above it. I could see that it's a ball. I'd be standing on it. But if I'm a little, tiny speck of dust on that thing, not even an ant, think even smaller than an ant, right? You can't even notice it. I mean, you could walk around. You won't notice that it's a ball. Yeah, because you can't see far enough. You don't have so if, let's say, for example, that you have a piece of paper and you write S on the piece of paper, right? Let's say that S could see. Does that S know that it's on a flat piece of paper or that it's on a round piece of paper? No, because it can't see high enough to know that.
I also want to make one point before you unmute him. If you want to prove that the Earth is flat, you better care about calculus, because calculus and objective science is saying you're wrong.
It's funny because calculus was invented by the same guy who he discouraged earlier in the debate.
Because he's so yeah, you're gonna have to unmute yourself. I don't think we can unmute you. Yeah, I think it has to be from that person.
And I think most flat earthers are looking at sort of the base math, where it's all coming from. And if the math is working on the presumption that things are a ball, things are a sphere, then the fact that...
here's the great thing about science is that the only time it ever works on presumptions is if those presumptions are generally accepted theories. So if I were to come and try to do, let's say that I were to try to do an experiment using Newton's laws of gravity, and I was like, you know what? I'm going to work on the presumption that the equations are a little bit different. I just jumbled them up a little bit and then I wouldn't get the same outcome
that your peers would.
Yeah, exactly. And so you could do the same thing with discovering Neptune, right? When they saw that change in the gravitational pull, they were like, what is that? Is Newton's law of gravity failing us? They didn't say, all right, well, let's just not use Newton's laws of gravity. Let's use some other, random thing. Let's presume that it doesn't. They were presuming that Newton's laws of gravity didn't exist that far out. That's what they were saying. They were saying maybe it only applies to Earth, therefore something that far away. But they still used it. They said, let's just run an experiment with it anyway, and boom, they located Neptune. So you can run. Science uses a ton of different presumptions all of the time to come to a bunch of different conclusions. The conclusion that's sound and holds up is the one that we go with. That's how we came up with the idea that the sun is the center of the solar system and everything is orbiting around the sun. That's how we came up with the idea that the Earth is a ball. If you look at there's a lot of different evidence. You can look at constellations. You can look at shadows and sticks experiment. You can look seeing further from higher, riding on a plane, looking at other planets, the existence of time zones. I mean, we can go on forever. The center of gravity. You can go on this forever with evidence that the Earth is round. So when you put all those together, it's very hard to say that the Earth is flat. Just like it's very hard to say that we didn't land on the moon. Just like it's very hard to say that vaccines cause autism. I mean, there are certain things that you can make presumptions about when you take all of the evidence that's already been discovered and you can make those presumptions.
And I would say there's people out there that are questioning the presumptions.
Okay, so what presumptions are you questioning?
The base presumption that the Earth is a ball.
Okay, so what about it, though? I mean, what presumption I just gave you a bunch of different presumptions that led to that, like the existence of time zones, center of gravity, other planets riding on a plane.
Sticks. Eratosthenes measuring the shadows on.
Okay, so shadows and sticks. Okay, go ahead.
The only way he figured that to be the circumference of the Earth was because he had to presume the Earth was a ball at first. Mm-hmm. Right? That was one of his major assumptions, was that it was a ball.
I mean, it's not that big of a leap of faith for
No,
and the
not
professional
for
field
somebody
is
that's
not.
already basing on the assumption that it's a ball, than for someone else to assume it's a ball.
But you have to have some sort of base assumption when you go into an experiment. For example, when they were discovering if something like I hate to keep bringing up this example, but Neptune, somebody said there's probably a planet there. They said, no, there's not. Well, they said, let's run this experiment, assuming that there is one, and see what we get. Boom, there was a planet. I mean, you have to make assumptions when you go into the experiment, or else you'll miss what you're looking for, right?
That's
You
a
have
scientific
to
method, yeah.
Yeah, you have to have some sort of idea of what you're going to be looking for. So he said, at the time when everybody thought that the earth was flat, right? These people that came out and said, okay, let's assume that it's round. Because remember, there were a lot of people before that thought that the earth was the center of the solar system and everything orbited that. And then there was Copernicus, who on his deathbed released all of his information that essentially debunked that. And he based it on the assumption, he made the assumption that, no, we aren't the center of the solar system. And he used that information, that assumption, to run his experiments, and it turned out to be a reality. So I think when you go into an experiment, you have to say, I'm going to base it on this assumption. Now, the assumption isn't necessarily always correct. That's why it's an assumption. But if your experiment pans out and you try other experiments and they pan out, exactly, it's safe to assume that your assumption is correct.
I mean, I can just give you an example, like with the zero property. If you take the opposite of the front and then you divide it by the back, you'll get whatever x is equal to. It's a kind of a quick way to do something, and you're welcome to test that out. You're welcome to prove it, but you'll find every single time it's the opposite of the back divided by the front, and that's going to be your x. It's kind of the same way, but I mean, if someone can disprove that, they'll be one of the most famous mathematicians ever if they could refute this kind of well-known idea. Kind of the same thing with the flat earth. If you could refute all the math and all the science and all the experiment and knowledge that kind of is established this into a solid theory, you would be incredibly famous. But we don't see that happening because there's really not any.
But we're trying.
Can you explain explain why snipers have to adjust for the Coriolis effect if the earth is flat?
I mean, I can't. I've not read from the 2 or 3 that I've skimmed through. I've not seen a single manual that mentioned the Coriolis effect. I've not spoken to any snipers that have ever had to adjust or knew the formula.
I think I can find the numbers. Yeah, I can find the numbers. I had it saved somewhere if I can find it. But yeah, essentially they have to adjust for the spinning of the earth.
Yeah,
I've heard that said. just not anybody that's.
Okay, here it is. Every 500 yards, it drops 6 inches. 1,000 yards, 2.9 inches. 1,500 yards, 7.6. 2,000 yards, 15.9. So that's like a whole other group of people that would have to be on this conspiracy theory. You would need snipers.
And by the way, let me just make this point. I think this is very damning. Maybe I'm biased, but this is very damning. Do you know how we keep satellites in orbit?
They just fall around the earth.
Exactly, fall around the earth. We know the speed at which it needs to fall towards the earth, right? It's actually falling towards the earth, but it's falling at such a speed that it continues to go around the earth, right? It continues to move around the earth, not only because of the earth's gravitational pull, but because it can do that because it's moving around the earth. Now, let's just say that there is no gravity and instead we're just moving up at a very fast rate and that's what's keeping us on the earth. It wouldn't be able to do that because as soon as it went under the earth, it would lose that momentum. It wouldn't be held by any force anymore. So the fact that we know the measurements that we need to keep something at a certain distance so that it falls toward the earth fast enough that it falls around it, right? That's pretty convincing evidence that the earth is not flat.
And I don't know if you guys believe in the flying earth idea to replace gravity. If you do, I'm just curious if you do or not.
I've not met one single flat earther that believes that ever in the 2 years and the thousands of flat earthers that I've come into contact with.
Okay.
Not
so
one.
What is your
met out that?
Okay, so what is your replacement for gravity?
I mean, I don't have one. Things fall down. I'll give you that.
Okay.
Yeah, things fall down, but how come they don't fall down in space then?
Well, I mean, couldn't tell you. I've never.
Well, but we can
What-
observe things in space. We can look at the asteroid belt, and we know that the asteroids aren't just falling, right? Because we would be able to measure the rate at which they're falling. Because so we know that the asteroids aren't just falling through space.
I
Right.
feel though if you're going to present me with a theory that the Earth is flat, I would hope you would have, in your 10 years of research, I would hope that you would have some sort of replacement from gravity that I can observe and test and at least logically walk me through it. Other than I don't know. I don't think that's.
Well, we've
convincing.
been studying this for a couple of years. James had been studying Freemasons and things like that for 10 years. So in
I
a
have a
couple of years, we don't really have it. And I apologize. I'm sorry that it's not to your liking that we don't have a replacement for the theory of gravity for you. I don't know what to tell you.
You should, though. That's the thing, is you can't come out with an argument and then not have all of the answers.
Look at us. Here we are arguing about it, and we still don't have a replacement for gravity.
Well,
Yeah,
our
but
argument
how
is
do you
gravity.
not have a replacement for gravity then? You can't say gravity doesn't exist and then not have a replacement for
All
it.
I said was things fall down.
But you can't just say things. Why do they fall down? Like, what makes them fall down?
I don't know. But what other answer do you
How
want? I
do
don't
you
know.
not know? You can't say things just go. That would be like me saying, I have to pee and I go pee without explaining why I go pee. There's something that goes on that causes me to urinate other than me just urinate. It doesn't just like come out of my dick, right? I don't just start like excreting fluid.
Right. I should just know the answer to everything. I got you.
Well,
Well,
you
the
should if
thing
you're going to
is,
make the argument.
if
Like,
you're
I'm not going to come
yeah.
out here and make arguments about things that I can't back up with evidence.
Like when you asked us about gravity, we tried our best to kind of present examples and explain it and give, analogies and all sorts of stuff that kind of supports this theory. So that's kind of something we were expecting as a counter.
I mean, things fall down. I don't know what to tell you. Grab something, it's going to fall. Going to
Yes,
go down.
okay,
I
but do you
would-
know
The
why
question's
it's going to
why,
fall?
Yeah. Our argument is gravity's doing it, and if gravity's doing it, then you're going to have you're not going to have a flat Earth.
What we're trying to
I
figure
shouldn't say
out
round, 'cause you
what
could
might
be
be
flat
causing it without assuming that things are a ball.
But you can't just.
Because
But
fewer
Okay, well, I have a question.
how come scientists thousands of years ago
I don't
were
know.
able to
I
figure
don't
out
I don't
using
know.
like you with modern technology,
I
you
don't know.
can't figure out a replacement for gravity, assuming the Earth is flat. Thousands of years ago, these people with their
Would-
telescopes and with
I think
just wanna
I
ask
think
you a
we're
few
all kind of
questions, if that's
stuck on
okay.
No, I
other
mean, I'd be happy
stuff
to
with it, though.
explain to
Can I
There's-
ask you just a few
job
questions,
and
if that's
life
okay?
plus the other stuff I'm doing. I got a lot of stuff going on. I don't know
Can I
what.
ask you a few questions, if that's okay?
Absolutely.
Would you agree in space things don't fall like they would at least in Earth?
I would not.
You believe they fall?
I'm not even sure they could get to space to be tested.
well, we know
Okay,
what
well,
escape velocity is. Like we've measured escape velocity.
We have like satellites in Earth, and we've had people
orbit.
in orbit. I'm sorry. We've had people there. You can even fly yourself. There's a plane where you can experience zero gravity. So I mean, I would say it's pretty set in stone that gravity is going to be different if there is any in space as it be on Earth. Is that a fair thing to say?
I would say that if there is any space, then if there is any gravity, that the
So you don't believe in
gravity
space?
would be differently in the supposed space, is what I would say.
Here's the
You don't
thing:
believe in
gravity
space?
doesn't just exist in space; it exists within things that have mass. So, like he was saying about like if you grab let's say Brian and I grabbed a big piece of cloth, and we both stood at other ends holding the cloth, and we set a small ball. Like let's say we set a small ball that resembles the Earth, okay, into the center of it, right? It would create a little dip. Now, let's say we set like a rubber ball, something much smaller in, it would fall into that dip and it wouldn't be able to escape that dip using its own force. It just can't do it. It would need some sort of alternative force to get out of that dip, right? Now, that would be escape velocity and that sort of thing. Now, let's say that we set an even bigger ball right next to the ball that's the Earth that also has the smaller ball next to it. That would create an even bigger dip that the Earth would now fall into, or the Earth ball, and that the smaller ball would fall into as well. Now, both of those, so as you can see, things with bigger mass have more gravity. Things with smaller mass have less gravity. So we can measure gravity. Now, you don't just walk into space and experience gravity, right? It's the things with mass that exist in space that have gravity.
And even if you don't want to call it gravity, you can call it whatever. If there's some sort of force acting upon it, it's going to not be flat. if there's some force acting on it, you would have to expect some sort of reaction to the mass. In this case, it would be the Earth. You would expect some sort of reaction against that force, which is why we would argue the Earth cannot physically be flat, or any natural, anything naturally in space would not be flat for that reason.
It's so hard to talk about space, though, because none of us have been.
Well, I mean, we can study it.
It doesn't matter if you've been to space. Other people have been able to get objectively, proven equations about what goes on in space.
Even if we've never been in space, we can operate on the idea that with some sort of force acting on Earth, you're going to expect an opposite reaction from it.
Yes.
Which is why we would argue that you would not have a flat Earth because there's a force acting on it.
I think
it wouldn't just be
I think the thing Josh was trying to say was just that the flat Earth theory doesn't really have a set of absolutes. Like, we're still struggling to find out why we don't see the Earth rotate under a gyroscope that our good friend has done an experiment. We're still trying to figure out why, and I'm not going to get mad anymore, because it's stupid, but I'm still stuck on why this P900 can see things it shouldn't. Like, we're growing.
I talked about refraction.
You guys agreed earlier that things do fall, right? They fall on Earth. Can we agree on that?
Well, I pick something up and it falls for sure, and I know that heavier things fall, and I know that if something's really light, it'll float.
Okay, so my argument, or what I'm saying right now, is if you're on Earth and you drop something, it falls.
Absolutely, of course. I'll give you that.
Mm-hmm. Okay, cool. So can we say there's something acting on that?
I can't. I just know that when I let it go, it falls, man.
Okay, so let me say this, all right? Let's say that there is no universal law of gravity, right?
Well, even if it isn't gravity, even if it's whatever,
it's something.
It's going down, and the masses. So physically, you're going to have a force upon that.
Yeah, well, here's a really good argument, right? Here's why it's gravity and it's not anything else. This is why, because Newton's laws of gravity have applied as far as we have tried to apply them, right? We've gone again with the base assumption that they exist, and we've tested them even outside of our planet, outside of our, and they've still worked. So you'd think that if there was no universal law of gravity, that things would be different and wouldn't work the same way in different areas, but everything does work the same way, right? All the universal laws of gravity, Newton's laws of gravity, work everywhere. And so also, it's really hard to say, because you'd think, like, if they weren't universal laws of gravity, then if I drop an apple in China, it may it may fall at a different speed in Los Angeles.
And also the argument that it happens in space, so we have to discard it just because you haven't been there or seen it. Well, have you ever worked with like a very powerful microscope?
Nope.
Okay, you need a really powerful one to see certain viruses that are very small.
Like micro.
Yeah, I mean, bacteria are bigger.
Yeah.
So you don't necessarily need a very powerful microscope to see it. You could use just the high school, microscope to view it. But once if you're like majoring in a health science and you go on and you're looking through these powerful microscopes, you can see viruses and you can see a lot about them. So if we're operating on the notion that because you can't see it, it's not there, or because you personally haven't seen it, it's not there. There's another conspiracy movement. It's AIDS denialism, and some of them believe HIV is not a real virus. And part of their argument is kind of similar.
I think they believe it was manufactured, actually, and that HIV being the cause. I saw something like that, but I hear what you're saying. Some of them either
flat out deny it, or they don't believe it's the cause.
Weird. I heard that,
people that believe it.
I hear what you're saying about the space argument. Yeah, I hear what you're saying. But the thing, the other hand of that is you could drop something in China and it'll fall, and you could drop something in America. If it's flat, it would do the same thing. It would fall there too, right? So it's kind of hard to, I don't know. For me, it's hard to pick either way.
I mean, if you really wanted to like look into space, I suppose you could, if that's the field you wanted to go into. And there are people that do that. They're not, Illuminati. They're not conspiring against you. They're just people with interest in maybe physics or space, and they study that for years and years and years. They observe it, and millions of people independently of each other, like I said before, they're not meeting up on the weekends at barbecues. They're not talking to each other, sending emails to each other. There might be a few people that they're colleagues of their friends, but that's not going to influence their work. Even if it was, there's millions of other people coming to the same conclusion. So it's kind of impossible for them to work together.
Right, but again, I firmly believe it's just a difference of opinion that only a few need to know, and other people, like good, honest people, go to their job and they don't know. They're just doing their job, You hear a lot about that. So I don't know. It's hard to say either way, but same with the space thing. I want to leave that alone. I want to really kind of talk about where we are in terms of the movement.
The people that
I don't want to talk about the movement. I want to talk about proof that you have that the Earth is flat. I don't want to talk about your movement. I want to know why you think the Earth is flat.
What about the people that
I told you, because the cameras can bring things that are supposed to be hidden in curvature.
Find me more evidence.
Gyroscopes. Here's a brand new topic. I have one of my best friends in my group did an experiment himself, and I have video. Let's talk about gyroscopes then. There's another thing, and I'm not an expert. I don't claim to be an expert on gyroscopes. He was just Josh. There are people who have done experiments and videoed it, and they're not seeing the curvature that you should after 6 and 12 hours. There are definitely some questions that need answering there.
Motion. There's no motion after 6 hours, no after 12 hours. It's not curvature.
Okay, so hold on a minute. I pulled up something here.
Why is it that snipers have to account for this and they use the math and they're able to hit their target accurately using these math? Using this math.
How is it that planes can land then? Isn't that the same kind of thing? If like a bullet's really small, would it apply to an airplane landing?
Well, not really, because a plane has to land at a certain area. Now that is another argument.
Yeah, but it's
flying
a
lot recently.
Yeah.
But when they descend, they actually do kind of account for that because they descend.
Do you
they
actually
don't nosedive?
Fly?
I don't personally fly. No, I've been flying.
Okay, listen. The Earth rotates too slowly to be detected by most gyroscopes. The static friction in the bearings and the imperfect balance prevents it from detecting that. Only like really expensive military grade gyroscope, ring laser gyroscopes, high sensitivity, special high sensitivity gyroscopes are actually sensitive enough to measure that. So I'm sure your friend's, Walmart gyroscope doesn't pick it up. But if you go and look up like a military grade,
hang on for 1 second, guys. That's awesome. Hang on, can I speak for 1 second? So you just said that's awesome, because when he did the experiment first, and he actually has an expensive one. When he actually did the experiment,
but he doesn't have a military grade one that's
but Rob Durham doesn't. He did it as well. Anyways, here, let me just get this through. So that was the criticism, that they weren't good enough to detect something small enough.
This wasn't that. I was talking about the static friction in the bearings, right? And the imperfect balancing.
Yeah. That too.
It would be kind of like if you bought a microscope.
So he basically took all that he did an experiment to show that the gyroscope was sensitive enough to pick up movement of 15 degrees or whatever the formula is. Then second of all, the second criticism he got was...
Which journal did he publish
a journal.
Yes, I'm assuming he published in a scientific journal, correct? So we can be peer reviewed.
Do you think flat earthers are getting a chance to do experiments in peer? Do you think they're even getting a chance to get into a science?
Here's the question: Were round earthers getting the chance thousands of years ago, or did they have to come up with it on their own? I mean, if you guys can't come up with it on your own, then you don't have a very compelling argument.
I just wanted to explain that the answer you gave as to why the gyroscopes don't work, he changed and adjusted that and took the criticism and then did another test, and it still didn't show it. And then the next criticism came, well, it's a cheap gyro, it's not military grade. So an engineer and a pilot who has a lot of money actually got a ring laser and a really good airplane gyro thing, and still no motion. That's all I want to say.
Yeah, I flat out don't believe they had the same equipment as him. It would be kind of equivalent to, I hate to bring this parallel.
Does he have a powered 3-axis gyro?
Did you see it if you believed it? That's the question.
How long was it continuously interrupted, non-narrated and everything? How long?
I believe 24 hours, the first one.
Yeah, and how long was and what specific latitude on screen was it at?
Are you able to live stream? Because we won't have any
You know,
content issues. This is actually our content. So why don't you live
If I
stream
could,
the video
it would be
and we can go through it?
It would be somewhat similar to saying, "Oh, well, they say HIV's the virus is in blood." So
I
let's
don't
take
want to
the
talk
blood
about
of-
HIV. We're talking
Well, it's
gyroscopes.
relevant because they're both kind of denial of consensus, and their arguments are so similar. I feel the need to bring them up because I feel you kind of see them as
Okay.
being silly and this not, but I think they're very similar. So if you were to take this and you use a particular microscope and you're like, "Oh yeah, it's definitely good enough to see it," oh, there's nothing here. Like with a microscope, I can tell you just a simple microscope. You know, there's different instruments and tools you have to use to properly see the specimen on the sample. Even basic high school ones, you have to know a little bit.
Okay.
Forget complicated things. So
I hear what you're saying.
my argument is it's not particularly compelling that he, number one, even had the right one, or number two, the systems and all the instruments were properly functioned for it.
Yeah, he could have easily jury-rigged a counterweight with bubble gum or something. I mean, if you weren't there personally to see the experiment, you can't prove that he didn't mess with it. This is your logic, by the way. This is your logic. If you weren't personally there, you can't prove that he did it without jury rigging.
All right.
And if it can't be peer-reviewed by everyone, it doesn't appear it's being.
I have a challenge for you guys. Do you guys have a gyroscope? I challenge you.
I do not own a gyroscope
and film
No,
it.
I don't.
I challenge you guys to get a gyroscope.
Okay, can I
film
give you a challenge, please?
I'd love it if it's practical, doable, repeatable, testable,
Sure.
and doesn't cost a lot of money.
Well, would you be willing to get on a plane high enough to kind of see the curvature and experience zero gravity? Because you could do that.
My dad flew on the Concorde and he didn't see it at 68,000 feet in 1998 from London to New York. So
I would be interested in you doing that. I have seen it. I mean, if you'd like.
Considering I just saw it yesterday when I was flying, I mean, I serious. Maybe your dad's like doesn't have very good vision, but
I mean, I could take a
but you
picture
said
for
that
if
everything is based individually on everybody's vision. Listen,
no. I didn't say. All I said was that the horizon line and the line in which perception changes is based on people's vision.
I guess the question is, like, if people keep doing these experiments and it keeps getting more refined and better to the point where, like, what will you guys do if you see a proof that totally shatters your beliefs?
The problem
like,
is
what if
it
the
has
gyroscope
not been presented.
To be presented?
So here's what I would do. All right, if you could prove, if you could prove,
okay, go ahead. A Nobel Prize in physics. I'd be famous and very wealthy. If you have evidence, give it to me. I'll publish it myself. I'll take the
okay. So the starting point of this is let's watch the video now and go through it. It's my team's video. Like we've done it ourselves. Why don't we watch it?
You said you weren't there for the experiment.
I mean, if I can be honest,
I wasn't there for the experiment.
So how you weren't there for this? So I could literally just. Now, okay, so now we've established it's okay, so I can bring up like scientific evidence that the Earth is flat with experiments that other people have done, even though I wasn't there, and you can't use the argument that I wasn't there, and so therefore it's false anymore.
No, if it's that important to you, we can get you the guy.
Okay.
He can come on the show.
No, that's cool. Yeah, no, great. Let's have him through. Also, I would like to, also talk about the moon landing now that we don't have to be there for these experiments anymore.
Hey, wait a second. You asked us to come up with 2 more proofs and shut up about the P900 camera. So I brought you the camera. I brought you gyroscopes.
I already debunked the gyroscope and you couldn't answer it.
What do you mean you debunked it? You told me there was criticisms, and I told you that I had a guy in my group that has done it and adjusted for the criticisms, and you're telling me you've debunked it?
Yeah.
If I Google searched the guy in your group, he would come up at this,
Where did he go to college? Can I ask that? Where's his PhD from?
Is that what's required?
I would expect you to be an expert in your field.
I think that's what science is all about, right? It's all about PhDs. It's all about making sure you get paid to do the experiment.
Well, no, but you have to be.
Hey, somebody with a bag of chips, Jesus Christ.
I expect you to be an expert in your field. I expect not just somebody Googling something and finding YouTube videos. I expect you to be an expert. I mean, when you go to court, they get somebody with a PhD as an expert for a reason.
So a natural curiosity and just a tendency to maybe run experiments. And
you can absolutely do that, but don't pretend that's.
But that's not science.
No. You're absolutely allowed to do that, but don't pretend that's hard evidence. Don't pretend that's equivalent to being an expert.
What if it's testable and repeatable, What if it's repeatable by other people?
If you can do that,
Science?
well, it has to be
But that's what-
repeated, and I mean, it's still science
Yeah.
regardless. It could just be very bad science. And
Well,
my
I
argument
think
is,
again, we're back to the whole thing here is I'm
my
not
argument is it
presenting
could be
any
very bad
evidence.
science.
I wasn't looking for any evidence. I mean, I didn't bring any evidence
Well,
with me to prove to you that the
I-
Earth is flat because I'm not going to be able to.
Well, I was kind of hoping for that.
Well, see, and that's not quite how things like that work. It's more of a revelation. I mean,
But see,
I can-
you could just
I can
as
show you
easily say it's a
information, but it still wouldn't have to come from the-
revelation that the Earth is round. But we have evidence for it. That's what makes it different. You can have a revelation about anything.
right. And again, these are all things that you'll come to terms with after the revelation. It's a questioning of the very basics of what you're not questioning.
Well, if you want something like the flat Earth to be serious, you're going to need more than you're just going to wake up one day, man. You're going to be.
Except I'm disinterested in what you think about the flat Earth. That's the issue. That's the issue. I'm disinterested in what you think.
There's a few issues with it. I mean, for example, we could get into like the moon landing because I know you guys don't you don't like our evidence that happens in space. Like one of my first questions was, why is everything else round and Earth is the one exception? So I guess the counter would be the other planets aren't round, which I would say they are. And
I would say they are. I don't say that necessarily spherical, but I would say they're round from what I've seen.
So why is the Earth the only thing?
Yeah, why is the frickin' Earth like just arbitrarily different?
Out of all the planets?
Don't say because humans.
But there it is. Yeah, I don't know. But there it is.
Okay, so here.
What would you say is more realistic? Earth is the one different planet, or maybe Earth is like every other planet we're able to observe?
Well, from what I've seen, we're
actually. This reminds me of a debate we had against someone who was denying evolution that said that all of the skulls we found from ancient humans were all deformed humans, and that it was just like a bunch of deformed humans that we found, and that's why that's why the skulls are different. Which is
even I'll say that's ridiculous. There's hundreds of thousands of transition bones. Like, come on.
Well, that's what I'm saying, and so I think like making the argument that the Earth, for no reason that we can understand, is the only flat thing in the entire universe that we've seen. I think that's
satellite
kind of same around.
Where's all that shit stored by Lucy and all that evidence?
They have that at the University of Arizona State, I believe. Yeah,
that should be in every museum everywhere. All those transition bones. I think.
How are you going to have Lucy in every museum?
Wow, there's got to be hundreds of thousands of Lucy's. Is what I'm saying. Anyways, we're not going to get into that debate at all.
You can go into other universities. They do have fossils. You can go to almost any if they have an evolutionary department. They'll probably let you look at it.
Let me ask you a question. What was his gyroscope designed for? Like, what specifically?
No, give me a minute.
There's a couple of different gyroscopes, and they're designed for different things. What was his?
Just a few of the things that could have gone wrong.
No, I have a whole list of things here, and I'm just going to kind of ask questions and see if you guys
give me a couple minutes. I'm going to pull it up on my computer and try and get some specs here. Give me just talk.
Let's talk about something else.
Well, I just want to talk about how difficult it is to actually build an ideal gyroscope for this kind of test. Like I said earlier, forces such as friction cause problems that make the unit precess. Such errors need to be corrected over time if you want to use it as a navigational instrument.
So you have to have changed it, yeah.
Exactly. For airplanes, that means gyroscopes that drive the artificial horizon are not unconstrained. A simple gyroscope with full range of motion would tend to maintain orientation with respect to the stars, right? But this unit would also collect errors over the time and wouldn't maintain that axis for a long period. I mean, there's a ton of different problems that could come up. A traditional spinning airplane gyroscope has a mechanism on the inside that assumes the aircraft is flying level most of the time. The local gravity near the vector opens veins that allow air forces to push it slightly. These factors cause the gyro to precess in exactly the direction that causes it to align with the gravity vector. So there's just a lot of different issues here that, I mean, it's really hard to get with the gyroscope a perfect 100% of the time accurate result because of so many influences that and different forces that play into the experiment, right? It would be like me licking my finger and holding my, hand in the air and being able to tell you when the next storm is coming.
Is that kind of like when Foucault did his pendulum thing 200 years ago? No one's been able to recreate it. Is that kind of what you're saying?
Well, there's some experiments. I think if you're going to prove it, I've been looking at gyro experiments. I've seen, some people, videos. I've been looking at them.
Have you seen any flat Earth gyros yet, or am I the one bringing it to you?
I watched a couple.
Okay.
I've watched. They're like 30 minutes long, so you have to skip through them. But I've seen and I've read the descriptions, and I've seen some. It seems like the gyroscope. There's some people who have said, hey, the gyroscope proves the Earth is curved, and then some people say the Earth is flat. So I'd like to see more of an experiment that shows the Earth is flat that can't also show the Earth is curved the day after. You know what I mean? I want to see an experiment like that.
This is what we've kind of been waiting for, actually. So you have like a very objective kind of like critiquing mind. So if we were to put together experiments based on your rigid kind of requirements, and then be able to show you that we can meet those demands based on your rigors or whatever you call it, then would you be open to kind of looking at something?
Yeah, absolutely. But it has to be. But the thing is, and here's the difficult thing, is that it has to give you the exact same result every single time. Like there can't be any difference, or else it's not an accurate test.
You're going to have to like refute like not just one or two studies, basically what millions of people have done. People that shoot satellites into orbit.
No, you're thinking too complicated. Just think on a small scale. A gyroscope. If I show a gyroscope to move to be sensitive enough to pick up a small movement on a turntable, and we know that the Earth spins once a day.
If you want to refute the round Earth, there's a lot of obstacles in your way. That's essentially what I'm saying. There's a lot of things you'd have to refute. A lot of people that you'd have to prove are lying. There's a lot of evidence. I don't think it's realistic for one person to do it in a lifetime.
Wait, so you don't believe the Earth spins?
Not at all.
Wait a minute. It doesn't move.
It doesn't move. No spin, no curve, dead flat.
Do you realize what would happen if the Earth didn't move?
You've seen that fear-mongering video? Is that the one you're watching? What would happen? They did a whole documentary on it. It was like a Hollywood special.
No, you're confused on what would happen if the Earth stopped moving. I'm talking about if the Earth didn't move at all.
Why does it need to move, though?
Because that's how we have the forces that are in play on Earth. Almost all of the forces.
But we can have those on the flat Earth, too. Like, imagine like a table with 4 pillars and a dome over it. Why can't we have forces on the flat table? Of course we can.
I mean, the things you're saying, like, for example, what snipers take into consideration, I fail to see how that takes effect without some sort of movement.
I don't know. I don't know about snipers. I know in our group, in our 2.5 years of going through this, we've come across many military guys, even in our own group, and none of them has said they have
Coriolis effect. Is that what it's called? I have the numbers here.
The Coriolis effect.
Mm-hmm. I don't even know about that, but whatever.
Yeah.
So how do you? Okay, well, let's talk about the wind, for example. I mean, the wind is caused by the Earth's rotation on its axis, right?
Why would you say that?
Because that's what it's caused by.
Wait, so the wind moves because the Earth spins?
The wind doesn't move. There is wind because the Earth rotates on its axis. If the Earth did not rotate on its axis, winds would blow from the north towards the south, and from the south towards the north as a straight line, as drawn from the equators. But because of
why wouldn't they go in a clock circle, like right to left or left to right?
Do in some hemispheres they do.
Yeah, exactly.
Both hemispheres.
No. I'm saying if the Earth didn't rotate, on its axis, winds would blow from north toward the south and from the south toward the north.
Regardless of air pressure?
Huh?
Regardless of air pressure?
Yes.
Okay.
So, I mean, we know the Earth is rotating because it causes wind, and this may seem like a cursory argument.
How far do you believe the sun and the moon are from each other? Because from what I have noticed from flat earthers is they tend to think it's very close. because that's kind of another thing.
In the northern hemisphere, it goes clockwise and counterclockwise.
Yeah.
That's in the northern hemisphere, and that's caused because of the Earth's rotation.
So the weather is caused by the Earth spinning.
No, the wind.
Oh, okay, the wind. Okay.
But can you refute that? That's my argument. It's like if the Earth didn't rotate.
Can you refute that if you're on a table, you can't have wind either?
So explain to me, how would you create wind that moves from east to west in the northern hemisphere if it did not rotate? Please explain that to me.
I think if there was an area of high pressure on the west side moving towards an area of low pressure on the east side,
what's causing that though?
What do you mean?
What's causing that? What's causing that drastic change in pressure?
It's a good question. I don't know.
It is a good question. I have no idea.
No, you can't say I don't know. I can explain to you how the wind moves and why.
What's the answer to the question? I don't know. I really don't know.
But then you can't have the thing. That would be like me saying, hey, there's a revolving teapot in the middle. You know what I mean? You just can't say that. I mean, you have to have some sort of reason for why things happen, or else you can't objectively say it, right?
If you're going to run like little Mythbusters experiments, you're going to have to like provide us with some answers to some very...
what I'm asking you isn't even that complicated. What causes the air pressure change that causes the wind to blow from east to west? That's not a very complicated question. Air pressure change occurs within our atmosphere.
You're totally putting us on the spot and
actually, it shouldn't matter. You should already know this.
But we've been telling you
your random experiment.
I run a political podcast and a political Instagram page. I am a host of a political radio talk show, and I'm sitting here explaining why the Earth rotates. You guys study this for 10 years, and you can't tell me what causes wind pressure changes or air pressure changes?
You're not listening to us. We have told you from the beginning. This is a new.
You said you didn't know.
Thing.
A new thing. 2 years of constant studying.
No, is that this fucking flat and there's no curve?
You can't just say that. No. You can't just say I know. Like you're not that woke, dude.
You just said earlier that you were like willing, like you didn't know, like you were willing to change. Why is it you know now? Like what is it that you know now? Like why this change of heart?
All I know is that I can't detect any curvature, and all I know is that I can see things using a camera that I shouldn't see on a globe Earth. That's all.
The thing is, like with your experiments that you're providing, I don't find them very convincing, to be honest. And there's so many experiments that kind of
you haven't even seen them yet, first of all. So wait till you see the video.
You've explained how about it to us, and we gave you.
I haven't. I'm not even a.
I really want to get this out of the way that you don't understand. You're making the claim. You're saying that I can't be right about why the wind blows because of the spinning. Bias. So here's what you're saying right now. You're saying, well, you're wrong about the wind, even though my theory is like essentially proven because it pans out. Right, that the Earth spins and that's why the wind blows the way it does. And I'm saying, okay, hold on a minute. And I'm saying, what's your counter argument? You're saying, well, it blows because of air pressure changes. I'm saying, why? I don't know why. It just happens. I'm giving you a reason for why the wind blows with my argument. Why can't you do the same thing? Your argument is so cursory.
Oh, I think you under the understanding that I give a fuck what you think. I thought we were coming on here to have a discussion, not a debate. If I'd have known it was my job to try to change your mind on something, I'd have let you know upstart that I wasn't going to do it.
The point isn't to change your mind. The point is
you should have known that you couldn't have changed. Yeah.
I did know that. I know I'm not going to change your mind. Again, I'll say it again. I'm not going to be able to change your mind.
So if you can't change my mind, then you can't. You're right. You can change my mind, but you have to provide me. You should. The fact that you don't understand how air pressure changes shows to me that, why are we even leaving Earth and talking about things like the moon, talking about gravitational pull and other areas of the universe? We don't even understand what goes on within our own atmosphere.
Well, you could have areas of warmer air.
Do you understand?
Area of colder air. Are we getting somewhere?
What? You cut out.
Areas of warmer air next to areas of colder air. Is that a little bit better?
Okay, what causes the areas of colder air and areas of warmer air? So here, the air, okay, listen, the change in air pressure is caused by changes in air density, right? And which is related to temperature. Warm air is less dense than colder air because of the gas molecules in warmer have a greater velocity and are farther apart than in colder air. There you go. This is called. There's a thing called the jet stream. I don't know if you know about this, but if you're flying into the jet stream, you fly a lot more slowly than if you're flying against, like with the jet stream at your back.
Yeah, like for example, in my room now, like I can feel breeze, I can feel wind, and I have a reason for that. I have movement with my fan, and which is an explanation for it. What we're kind of looking for is a reason behind that, some sort of logical answer behind it.
Behind what? What makes it work on a flat Earth?
Yes, because you have to have some sort of something starting it, essentially.
Yeah. Okay. So here, like, there is a start to things that happen, right? Okay. If the Earth was flat and the Earth didn't spin, there would be no need for something like wind. It would have the planet would have adapted differently. Things would be different, right?
Maybe.
What do you mean maybe?
Well, if the Earth is flat, then things are exactly the way they are, and that's the way they've always been.
Yeah, but how come there are things like the wind and the way the wind blows that would work perfectly with the Earth rotating and at the speed the Earth rotates? By the way, this isn't just the Earth this is the speed at which it rotates and the way it rotates.
Yeah, also when we shoot satellites into orbit, we take into consideration that it's spinning. Like,
yeah.
Unless you don't believe there's any satellites.
Which there objectively is. I mean, one of the hardest things when we launch things into space, there's so much debris in space left over. By the way, there's debris, there's trash in space left over from the voyage to the moon, right? There's legitimately in space debris left over in orbit around our planet from our voyage to the moon. In 1969, there is literally garbage in space left over from it.
So, serious question: what happens when the over 300,000 satellites hit that garbage? Is that like a big thing for satellites?
Well, essentially, what happens is it depends on how quickly it hits the garbage. If it hits it at such a rate that it's moving faster if it's moving. So let's say
how many satellites do we lose a year to space junk and asteroids?
China. A lot. We have a lot of space junk. In fact, we have so much that we might actually trap ourselves within our own planet because we can't get out again without hitting a piece of space junk.
How much money are we talking? Like, so seriously, you guys are serious? Like hundreds of satellites fall down every year?
No, they don't fall down, right? They are always falling down. They're just falling at such a rate that they're staying within the...
No, but like the busted ones, like how much does NASA blow on replacing satellites every year if they get hit?
I don't know the exact numbers, but I know that what China does is something where they blow them. So essentially, have you ever thrown a snowball at like a wooden gate and it just kind of blows up? Yeah. Well, that's because you're throwing it at such a speed that it's stronger than the molecules holding the snowball together. So it just essentially deforms as soon as it hits it. That's what China's been doing with its satellites, is that it's just running them into each other at such a speed that it completely destroys the bond of molecules holding the satellites together. So it releases all this junk into space. It's terrible, but that's how they destroy it. So they launch a new satellite and they go, "Hey, destroy the last one," and they go up there and so.
And it's not just NASA, by the way. There's private companies that shoot satellites into orbit.
Another totally serious, not mocking question is: how has the Hubble been able to stay out for 10 years without getting smashed to bits? And again, I mean that
because it can be outside of the danger. Well, okay, so
it's also a very big.
Everything moves at a certain speed.
Make it get hit more. That's why I asked. Sorry.
Well, no. Everything moves. Everything moves at a certain speed, right? So. Let's say that I were to put something out into space at the speed at which it needs to fall in order to stay in orbit, right? If I put something out in space at that speed, it probably won't bump into something else unless I intentionally make it happen, considering that most things in that exact orbit is moving at the same speed. So at different areas, well, hold on, let me just finish explaining really quick. I promise it'll be like 2 seconds. At different areas of orbit, things need to, so the closer you get to Earth, the faster that thing needs to be moving. So if something's moving at the exact same area, if there would be a collision, it would be moving at the exact same speed, so they wouldn't hit each other. What the fear is that we would launch a rocket into space and that we would run into some of the space junk because we have to get through it to get out of the outside of it.
Which must have, well, it should have happened already, but so, okay.
Well, we can calculate where it is.
That's a big,
so that's.
It just doesn't make sense to me that there's like literally hundreds of thousands of satellites right at the edge of space or whatever. So is each orbit has to be at a different plane? So is it like almost a bandwidth? You have to put them in certain spots so that these million or whatever don't hit each other constantly and blow up?
Well, it depends on what you want to measure. See, the like, if you're going to measure weather patterns on Earth, it needs to be closer, and it needs to be within a certain level of the atmosphere, so you can detect wind pressure, air pressure changes, and everything like that. So it would need to be closer. Whereas the ones that are, detecting different things, like if you want to check, I mean, I can't think of a specific example. Or for GPS, it needs to be farther away. If it needs to be farther away from the Earth to detect that, right? So let's say that. So
is there a program again?
I can actually send you. It's a really crazy, dude. There's a video. NASA has it up on their website. I think you can actually in 1080p watch the space junk. It's freaking gross. Let me see if I can send you a link to this.
Does it have satellites in it mixed in with all that?
Yeah, well, you can't like specifically see all of it, but you can see all of the. I mean, it's like, well, I'll send it to you. Hold on. I mean, they know at which speed everything's moving at because you can.
There it was 17,500, and I was like, how do they take pictures from the ISS if it's moving at 17,000 miles an hour?
Because they're like some cameras can take pictures of things at like high speeds.
17,000 miles.
Well, I mean, like you have
it's a really good camera.
If you're riding in a car and you take a picture out of a window,
it's a P90,000.
Yeah, exactly. Hold on, wait. Let's see if I can find the space junk. This is just absolutely. Let me see if this is it. Hold on. Is this it? Oh yeah, this is like a picture of it. I'm gonna try to show it on the screen for everybody to see, but it's like, it's freaking gross.
I don't know if you can play it live. It might kick you off the. Well, maybe not for you. It does for me because I'm on the app.
And just so I play devil's advocate, flat earther here, but is it CGI what you're going to show, or is it an actual picture?
Well, it's essentially I can't find the 1080p one. I don't want to like try to search for it and just be distracted. But this is essentially just like a picture. It's like an animated picture with a bunch of like showing where the debris is in our. Here, I'll show you. Hold on.
Okay. So it's an animation of exactly like how much junk we've actually left, our polluting ways.
Yeah, well, and then it has like a thing underneath it. I mean, it talks about more than 500,000 pieces of debris are tracked as they orbit the Earth. They all travel at speeds up to, like you said, 17,500 miles per hour, fast enough for a relatively small piece of orbiting debris to damage a satellite or spacecraft.
Whoa. So what happens if the fucking ISS gets hit with a pebble?
Well, the pebble would be destroyed because the speed at which the pebble is moving at is so fast that like it would break apart immediately as soon as it hits that because it's stronger than the bonds holding it together.
That went over my head, but I'm assuming that's the same kind of thing when the moon smashed into the Earth, it disintegrated instantly or something like that. Right?
The moon didn't smash.
It's like throwing a snowball, like I said earlier, throwing a snowball at a wooden barn door. You throw the snowball faster and it's moving at such a rate that the collision is more powerful and stronger than the bonds that are holding the molecules of the snowball together, so it just explodes when it hits the barn door. That's essentially what would happen if a piece of debris hit the ISS, is that the piece of debris would be destroyed, but not the ISS because it's bigger.
Okay, so in dumb terms for me, I'm shooting a bullet at a wall, and instead of the bullet going through the wood in space, the ISS is going to make that bullet disintegrate.
So have you ever heard of an ICBM?
Intercontinental ballistic missile?
Yeah, you don't necessarily need to have an explosive inside of an ICBM. You can just launch an ICBM and the force at which it collides with what it's going for will cause such an explosion because the molecules are ripping apart that it will cause a catastrophic explosion.
Oh my God, totally unrelated. Sorry. And this is a normal thing too. Line of sight. I was just heard one of my guys in Australia just heard a radio show of a military guy. Sorry, I'm getting excited. He called in. So they're doing targets thermally. So they're using Doppler to pick up their target, right? Which makes sense. And then he's like, but we use a 2-inch ring laser to actually light. The second step to locking on is using a 2-inch star ring laser line of sight. And he was like, I never thought about it. How are we able to use that laser over 34 miles to line of sight, like pin a target?
Wait, so from
And,
Tuesday,
I'm not
If
saying
you're
that's
shooting
a
a
flat
miss-
Earth proof. I just want to know how you would explain it.
If you're shooting something out, usually a lot of the lasers come from above, like from a drone, at least in the United States. And
No, he's holding it. He's holding it as far like he actually has to do it himself, line of sight. And I heard,
Well, I mean, you can, if you had like a
That-
hill, you could get a laser over the hill to a point beyond.
they're on flat water. That's what I was like,
Well, it
totally
doesn't matter if it's
unrelated. But
flat water. It could
so
be
wait a minute,
anything.
where are they shooting the laser again?
so they're
Australia,
using like
right?
so. Let's say the
It's in
Australian.
Australia, right?
I think it was. He was a military guy, so he's on a boat. He's military, so they use
Okay.
Doppler, which is cool. Obviously, we use it for weather. So pick up a target, and they're looking at targets 30. I think it was 32 miles away. So the Doppler picks them up, right? Just a satellite, sure.
Yeah.
But
yeah.
to actually
satellite in
complete
air.
it, so to complete it and to actually make it work, he has to stand on the ship and use a ring laser to actually sight it. He can see. He's using a ring laser that will actually light up a target 30 miles. And even him, he's like, I don't know. I know the Earth is whatever. He was asking about the curvature formula.
30 miles
because he's
isn't
like, I
that
don't
far,
even
though.
know.
Yeah, 30 miles isn't that far.
But
I'm
how
not that
much
impressed by
curvature
30
would
miles.
be?
I mean, you could.
Let me
no,
check the
I
exact
just-
curvature
yeah,
in 30
yeah,
It
miles.
wouldn't be
Yeah,
that
yeah,
much.
let's see,
It would be
'cause-
minimum.
Because even
I mean,
him,
if he's
he's like,
standing
how
up,
can
he's
I
gonna be
paint the
above the
target?
curve.
And the guy on the show was like, well, you have a big antenna. And I was like, oh, of course, yeah. But
Well, if he's
for the
standing,
Doppler, I mean, for the Doppler.
Here, I have an Earth curvature calculator. Let me so what was his eye height?
how tall is he?
Oh god, I have no idea. He's on
Just say
a
6 feet.
Okay,
That's
we'll
about
say
right.
6 feet.
say 6
So
feet.
6 feet, the target distance is 30 miles. Let's see. The horizon line would be 2.99547 miles. The target hidden height would be 486.175 feet. So it is possible. I mean, I'm looking at it right now. I can pull this up on the screen if you guys like. And we can put in any equation if you guys want. We can figure this out. I love this website. Hold on, let me.
So he can paint the target with a laser. Like he can use.
Yeah, you
and
can
would
do
be
it.
straight.
If you change the height at which you're at,
Plus, he's on a bow. He's not.
Yeah,
standing.
exactly. Well, and let's say he just got up higher. Like maybe if he was on like the deck of the boat, and then he went up to maybe like the observing deck or the captain's area
It'd be even
higher, he could see further. Yeah.
I'm gonna look at what the model of the ship was and where he was, because that would help our equation.
Let's actually measure the exact distance. Yeah,
Can I
because
ask you guys a question while you guys get your information from your guy?
yeah. Let me
Just
share
out of
screens really
curiosity.
quick. Go on.
How old do you think the flat Earth is, in your opinion?
Can you see that right there?
Yep.
So there it is right there. So see, here's he is, and here's the target. See, he could see it. Yeah.
Wait, where? So sorry, what's where?
So okay, so he's HO, that's eye height. Then DO, target distance, he's 0.
So
this
let's see, we'll go easy. We'll go 30 miles. So I'm Canadian, so we use kilometers. I think they do in Australia too.
Well, here's kilometers then.
Okay. So
But it comes to the same thing down here, regardless of like what you guys.
So 30 miles, we should have, how much should be hidden or whatever?
The target hidden height should be 486.1575 feet.
Okay, so is that like a lot? I don't know. Feet is.
Well, it depends
You
on
could
how. Well,
still hit it.
here's metric distance right there. It's
How
140.
tall are the boats actually? Are they taller?
Well, the
that's
question
really
is, see, like, so
considered.
here's the thing. Let's say that he wants to see 30 feet and he's 300 feet. His eye height is 300 feet. See how much more he can see. See the horizon distance changes the higher he gets. Let's say he's like 3,000 feet, right? It like literally, like it changes. It's insane.
Okay, so I gotta figure out what ship he was on, and
6 feet. Let's say the target distance was like 6 feet away.
Yeah, I mean, the height of the boat adding to that would only give him more distance.
Yeah.
So we're assuming he's right in the water, which he's obviously
So-
not. He's somewhere on the boat.
Let's just say one off that this is something that he actually is true and he could see beyond it. What would you guys say? How would you answer it if you actually were like, I can't explain this?
I mean, it
I
seems
would-
to match
so-
fine.
what I would do is I would have a lot of questions. Like, I'm going to stop sharing screens now. I would have a lot of questions such as how high was he standing? And I would look at calculations and things like that. I would also like want to talk to him individually and want to talk to people. I would want to recreate the experiment myself, or maybe send somebody out there that knows exactly about it and explain to me how that's happening. You know what I mean? I would want to know all the information before I came. I wouldn't just say, well, I would want to know.
From what you gave us, though, it doesn't seem to be anything game changing. It seems totally normal.
Yeah, I just found it interesting that he himself, being, just him doing it for like whatever years he's been doing it, that he just, because of the flat earth theory, called in. It was like, hey, why is this? Supposed on the curvature, I shouldn't be able to see this. And yet I've lit up targets, even 80 kilometers. What did he? I think he said even up to 60 miles. He's lit up targets. So I'm going to find out the military stuff. I'm going to start searching on ring lasers, and I'm going to find out what boat he was on and the height, and see. The first thing should be, is it greater than the 400, or hopefully the boat is higher than 400 feet, because otherwise, but we'll look at it. Awesome. So anyways, what were we talking about before that? We were talking about, before I said about the military guy.
We're talking the space junk. Here, I can show you a picture of the space junk. Hold on. Let me did I close the space junk? Let's see. And here it is. So this is essentially, can you guys see that right now? Oh, I forgot to present to everyone. Fitch.
I can see flat earthers use that all the time, and they're
look at that
how
space.
Come we can't see them? They're like, how come we can't see that from Earth?
Well, I mean, could you see junk from a mile away even? Could you see your neighbor's trash from?
It depends on the size of it too. I mean, I forgot. I used to know a lot about the human eye and what it sees.
You have to take into consideration like the clouds and everything else, kind of that could obscure it. How far out it is.
Pollution's a big thing too.
You can't even see stars that well.
Like you can't see stars from. I remember one time.
Hey, but we can see the moon at 450,000.
Well, the moon's very big. The moon's very big and it's much closer.
It was interesting. The power went out in Los Angeles. I forgot what year it was, sometime in the 90s. But people were actually calling 911 to say there were strange lights in the sky. I mean, these people had never seen the stars before. It was insane. And then the light pollution went away and they could see everything. It's really amazing if you go out. I live in Kansas. I live in the city, but I can go out 45 minutes and I'm in the boondocks.
I'm going to make you do a flat earth experiment because Kansas is so flat.
I'll do a flat earth experiment.
We got to get you doing one.
I'm open-minded about everything. I come to my opinions with objective fact, and so that's how I've come to I didn't just say the earth is round because I was taught that in school. It's something that I've looked at the evidence, and that's the conclusion I've come to, right?
Yeah. A lot of people say that, just to go with it, like a lot of people say they started out trying to debunk it. So I don't know. You hear that a lot in the community.
Well, I actually looked up, the first thing I looked up before I looked up anything when I was preparing for the debate was proof that the earth is flat. Mm-hmm. Before I looked up any facts on my side, I looked up proof that the earth is flat just so I kind of look at your guys' arguments that you're going to be using. Not that I knew you guys, but seeing exactly what, was going to come.
It's brutal, though. If you do that, it's brutal. You get the worst information. You get links to the Flat Earth Society, which is doing nobody any good. And you get a bunch of crock hogwash that makes people ridicule us at first, really. It's kind of frustrating. But the reason I stick with it and we're not yelling anymore, which is great, is because I see lawyers, doctors, engineers, pilots, they're all giving this kind of like an actual real look. So it's kind of like making me go, you know what? I need to look at this. And the more I look at it,
let me ask you this.
See, yeah.
What type of evidence would I have to provide you with? And you can all answer the same question because obviously it goes two ways. What type of evidence would I have to provide you with to prove to you that the earth is not flat?
You probably have to be able to do an experiment that can show me that the earth, maybe do an experiment to prove the rotation that we can do ourselves together. Mm-hmm. You would probably have to thoroughly explain how the P900 cameras are able to shoot things that shouldn't be shot. Mm-hmm. And you would probably, that would be a great start. I mean,
what about time
gyroscope.
zones?
Time zones is so fucked up. I don't know. I can't speak to time zones.
Like, you definitely acknowledge if I were to call someone in China right now, it would be a different time than it is here in the States, right? You would acknowledge that, correct?
But it wouldn't have to be if it was one flat place. It could be it's time. Time is time. Why does it have to be based on location?
But why is the sun not out? Or why is the sun out in China right now? Like, you acknowledge that happens, right?
What we believe, and I think you kind of alluded to it earlier, we kind of feel that the sun and the moon are closer, and they rotate over the dish or
kind of
whatever.
like at an axis. There's like a bar in the middle, and then it rotates around to the top.
Yeah,
of that.
Actually the North Pole is that center axis, and the North Star, the actual Polaris, is the center point. That is
how far away from the Earth is the sun?
They use, and I don't want to speak to it, but they use math. They use I think it's a Siderean theory to triangulate the position. Again, it's roughly 4,000 miles, or roughly the same.
So, but the
sun
is 484,000 miles across. So how could it be 4,000? Yeah, it would literally be inside of it.
But and again, they actually are thinking it's much smaller in diameter and much closer.
But here's the thing, though,
like sunspots and stuff. Like, if you look at, have you seen the sunspots from like 100,000?
Well, but here's the thing.
Really, yeah.
This is just a little like when we were talking about like the gravity before,
Mm-hmm.
we were talking about how like things with smaller mass have less gravity. So if the sun were to be significantly smaller than it is right now, it would have less of an effect. Yeah, everything would be different. Like Pluto would not move and orbit the same way it does right now, because that's based on measurements that we have about the gravitational pull of the sun based on its mass right now. So everything would be different. All of our calculations would have been different, if that makes sense.
It didn't, but I'll concede. Yeah, I'm sorry, I lose me with that. But what we let me see what.
So what about with Mercury and Venus, where it's much hotter? Like, how wouldn't it be?
I can't, man. I wish. I don't even have the smarts. I don't even know what you would even begin to start to measure it. Like, I don't even know, man. I'm just simply saying, like, this is where we're at, and this is why I stick with it. Like, if you did those things, I would probably be like, you know what? You're right, man. It's a globe. And that happens. And that's the thing about flat earthers too, that I'm noticing, is they're kind of open to adapting to things. Like, nothing's concrete until we actually can prove it. Which is why a lot of the times nobody's happy with us, because we're like, we don't know yet. We really don't, but we're trying to figure it out, But anyways, sorry.
So could you maybe like submit that the Earth is not flat right now, just until you get enough information to prove it is?
No way.
But could you just say that maybe the evidence that we have at this point leads to the fact
and simply because of the curvature. There is no curvature that I can see. My friends can't see it. There's experiments we've done.
Well, that's because that's the
holding point.
The reason that we can't see it, we're so small that we can't see the curvature. We don't have powerful enough eyes.
Microbe on a basketball.
Okay, if you climb to the top here, a really good experiment to prove that the Earth is not flat is, number one, the tallest building in Dubai, but also climbing to the top of Mount Everest, 29,000 feet and some change.
Which anyone can do.
Climb to the top. Yeah, anyone can do that. Well, not anybody.
Have you seen the pictures from 100,000 feet and all the air balloon stuff where it's like dead flat at 100,000?
But if you look, I can send you pictures that people took, different people at the summit of Everest. You can see the curvature of the Earth. I mean, you can physically see it.
But are they using, then you get into the fisheye argument, and I'm just kind of giving you guys the flat Earth basics. Like, this is what you're going to come across. People are going to say, yeah, well, you can see the Earth from a curvature. It's a fisheye lens. And I looked into that. I'm like, it can't be. But then you actually go to GoPro's site and you're like, yeah, oh, wow.
But the thing is, if you look at pictures, let's say that I looked at.
I also have a question, because I've done a similar experiment.
Let me just because this is an interesting. So you can look. I'm assuming when someone goes on an expedition, they bring a couple so the pictures they take of themselves climbing the mountain if you're using a fisheye camera, then you would be distorted as well. They're not distorted. So they'll take a picture of themselves, like maybe even a selfie you could see the curvature behind them, and they're not distorted at all. If they're using a fisheye camera, then everything in the picture, I mean, it's obvious when they're using a fisheye camera. That's why I don't use GoPros when I record my...
Have you guys seen, and I don't want to misquote it, but have you guys seen he's not a flat earther. He wasn't. He's an actual like experienced mountain climber, and he climbed just kind of like what you're talking about. He did like 3 mountains that were the same height, but maybe 50 or 30 kilometers apart each one, and he kind of did that with vector. That's one I've got to send to you, a climber, because he wasn't a flat earther, and then he started doing these climbs, and then he looked at his footage and did the math. He's like a math guy too, and he's like, okay, I'm not a flat earther, but what the fuck is going on? How am I able?
See this right now?
Well, another thing you have to consider is
do you see this?
Nope, black screen still.
Okay, I just put. Do you see this now?
Yep.
Okay, see how the guy's head is in the picture? Like he's there in the picture.
It's not distorted.
It's not distorted at all, but you can see like right there. I don't know if you can see my mouse. That's clearly curvature going on right there. I mean, that is the curvature of the Earth. You could tell. And he's not distorted. If it were using a fisheye camera, he would be. This is just one example of that. He would be distorted as well. That, like, if I've done a podcast before,
I think you're right. You're right. You know what? It's actually the pictures from space and from like Red Bull and all that where they use the fisheye. Like that, I will agree. That's probably not a fisheye because of what you're saying.
I was give a similar example where I did an experiment with, it was just interning, but basically with a bunch of kids, they put a weather balloon really high in the atmosphere, and you wouldn't see this distortion until you get to a certain height, and you can clearly see that there is curvature. And then obviously if you bring it down and you film, you don't see this distortion. The only time you see it is up in the atmosphere where we expect to see the curvature.
So have you guys seen I saw that one, and if you watch the whole thing, you can kind of see the
I don't think
you can see the way that like when you reach the atmosphere. Was it the Asian girls that did it? The 2 Scroll girls? That was pretty famous. Oh, okay.
I mean, they might have done one, but that's not the one I did. I wasn't with that.
I will send you the picture. It's actually really famous. You've probably seen it. It's the white atmosphere with the dead flat at 100,000. If you've looked at flat Earth, you've probably seen it. That's kind of an interesting picture to kind of start looking at too. But one of the things I was thinking, because you guys seem to be interested in the flat Earth, or talking about it at least, is maybe we can kind of get you guys to rebut the basic flat Earth arguments. Like, I'd love for you to rebut the P900. I know you're going to look at it later, but like maybe we could set up something where you guys give us some criteria, or me, and I bring you the opposite, or the proof.
Let me see if I can. Give me about 5 minutes here. I don't mean to sound like I'm like, I'll give you 5 minutes to debug. Let me just see if I can find on.
So if you were able to get on a plane and you were able to see the curve, would that convince you?
Not at all, because I have been on a plane. I've flown many times, and I've never. The one thing you notice when you're flying. I've flown to Fiji. I've flown to Australia. I've flown probably everyone, even back in the day. Eastern Blue, America. I've flown every single.
And another thing you have to take in consideration is kind of the clouds and what you can and can't see. That can obviously distort it. But I mean, there's definitely a lot of accounts that people that certainly aren't conspiracy theorists showing clear evidence of it.
Yeah, here's one you're going to get all the time. How is gravity able to hold 1 trillion tons of water, yet allow a butterfly to fly over the ocean?
Wait, what were you saying?
A butterfly evolved with gravity already in place.
Yeah.
No, but I'm just telling you, these are the kinds of things, like gravity can hold, like the gravity can hold our water to a spinning ball, but yet, things can fly and this can go. Like, those are the arguments you're going to hit for sure.
For example, water or ice is the density changes depending on its state. So like if it's a solid, if it's ice, it floats, it goes up. So water is a very unique element. It being polar, It's very
Water's
unique.
always flat too. It always finds its level.
Well, no, water always takes the container that it's in. It's not flat, it's whatever it's in. If you have a square box, the water's going to appear square because it's just conforms to what it's in. A butterfly, that gets into evolution and how butterflies evolve, and I'm sure there's a very specific evolutionary answer in the mechanics of it. But essentially, their environment required the best fit in that environment to survive, and that happened to be the ones that could travel further, which makes sense. So that would be my response to that.
Yeah, there's going to be a lot of kind of little things like that you're going to get thrown to. I just I'm excited to get you guys going on the gyroscopes and on the camera thing, because I mean those are like there's so much.
So I'm looking here. I mean, this is a lot, but essentially he was taking pictures of the space station. I mean, I can send you guys the link. He said the above sequence of images is the International Space Station. I took them on Saturday, May 28th, 2016 at 9:28 p.m. in the Northern California town of Shingle Springs, which is near Sacramento, I guess. Maybe everybody have shingles. They're not very good, but you could still make out the general shape of the ISS with the central body and the solar panel off to the side. And then he took another one on September 29th, the same location with a bigger zoom.
I have another stupid question. How is it that we can see that thing when we can't even see a plane at 30,000 feet? But we can see that sucker.
He's using a camera. Perhaps the reason why this evidence is ignored is that it's hard to duplicate. You can't exactly take out your iPhone and take these pictures. The ISS is 250 miles above the Earth's surface. Let's see.
And how
I'm just looking through.
Can I ask you guys a question, just out of curiosity? What exactly is how you guys explain like the change of seasons?
So the pictures that he took are only possible, and he took it with the P90's 83x 200 millimeter zoom. The pictures he took would be impossible on a fake Earth, because at any location,
A flat Earth.
Yeah, because its appearance at any location is precisely predictable, but only if an orbiting globe shaped the Earth at a certain speed and at a certain altitude. So he has a whole list here of the locations, exactly where it'll be. So what he did was he mapped out exactly where the space station would be in its orbit around the Earth, and then he took a picture of that, and it was right there. And that's implying that the Earth is round, like we were saying before. Something in orbit falls at a certain speed, and that's what keeps it falling around the Earth. Something in orbit is just essentially falling around the Earth. So he knows exactly where it's going to be at that specific time. He takes a picture of it in that specific place, and that's where it is. Whereas if the Earth was flat, that same math wouldn't pan out, and it would be in a different spot. He would look, and it would be in a different spot. Does that make sense?
If it exists at all, but yes.
The International Space Station?
Mm-hmm.
I mean, it does exist. I mean, he's taking pictures of it.
You have to look at. There's one by, I think it's Russian. I won't say names.
I think we even have video of it.
There's
being
some
shot
funny
in space.
There's no footage of it being built though, ever. In space.
How would you film? Like, what do you mean? There's footage of people working on it all the time.
No, but you would think that they would film, like, again, like, this is space. It's motherfucking space,
Can I
people.
ask the point, like,
why wouldn't they show it 24 hours, them building this sucker? I would. That's just me.
Well, the thing is,
there's a constant 24-hour feed that they have.
Yeah,
you can
they do have a feed.
Flat Earthers will say it drops every 8 hours. I did it once, and it did go blue screen a bit, but they will argue that, and NASA is apparently taking it down now. And then they're going to say, too, the first thing they'll say is like, yeah, they always do the little pre-planned outside. They're going 17,000 miles an hour, yet they're going to take their little wrench and do adjustments with all that space debris and asteroids.
But the thing is, like, we already talked about the space debris and how it's like, the area around. Oh, sure, it's dangerous, but I don't think space debris is the biggest. I mean, the fact that you're in an area with like essentially a vacuum with no oxygen is a little bit more dangerous than the space debris, right?
Dude, I'd be shitting my pants if in the space station. I literally.
Do you realize how big, how expansive space is? I mean, the space debris is very far apart. It's not like they're on each other's ass. Like, I mean, it is very far apart.
If we were to look, what's orbiting at 250 miles? Anything? Any junk or just the ISS?
I mean,
what's at 250 miles?
That's the ISS, I think.
Yeah.
There's nothing else on that orbit.
Well, we could look. I mean, I can't. I mean, I would have to. I could look, but I mean, I don't know exactly what's orbiting at that same.
Oh, the other thing like it's just hard to because you're going to deal with people who are thinking about like Earth, down to earth things, so they're going to be like, well, I drive a car at 200 and I'm literally going to fall over, but yet this astronaut can whiz around at 17,000 miles and he doesn't disintegrate.
Well, no. The only way he would disintegrate is if he ran into something and he was moving faster than and more powerful than the bonds holding that item together, right?
Okay, but just think about it on Earth here. Think about you running 100 miles an hour. That's fucking fast.
Do you know what causes something to disintegrate?
Probably
like an asteroid. Let's just like a piece, like let's say a meteorite is whirling through space, right? It won't disintegrate until it reaches our atmosphere and burns up in our atmosphere. That's shooting stars and things like that. That's why you see that.
Why don't they burn up? I've heard like aluminum and all that shit. The ISS.
They burn up. Why? Because they're not being impacted by our atmosphere.
They're not being pushed down at that speed.
Exactly.
Sorry, again, ignorance. What's the temperature at 250 miles?
Let me check.
And what is the equipment rated at?
It's going to depend what it's against because that gets into friction.
Yeah, right. Exactly.
So
well, see, that's why, like when we're returning from the moon, I mean, it's a meteorite would burn up in our atmosphere. It's not going to burn up moving through space because moving through space, there's nothing there to burn it up. It's a vacuum, right?
So how does a rocket work in the vacuum? By the way, that's another thing. And does a rocket work? Would it work in a vacuum? And here it is. Here, sorry. This is just my own.
It's propellant. You propel it, right? So let's say, okay, so here.
Vacuum going to a vacuum.
Okay, let's say this. Okay, let's say we're in space, right? And you're holding on to a rope and I'm holding on to a rope. If I let go of the rope, I'll be in the same spot. I'm not going to move because it's a vacuum. There's no force that's going to push me to the side. Now, if I push off of something, right? If I push off of the ship, I will continue to move backwards very slowly.
Something else moves you, yeah.
Exactly. If let's say we propel something, this is where the math comes in getting to the moon, right? This is why it's so important. We propel something at the direction of the moon and it makes its way there, right? Now, that's how you have to, I mean, so if you just like dropped, let's say we just carried a rocket to space and just released it, it's not going to just go to the moon. Like it can't move on its own in that vacuum because there's nothing propelling it. It has to propel itself. Like if you were to drop an apple in space, it wouldn't fall. It would just stay in one spot, right? Because there's nothing moving that apple.
And there's also other methods we have to travel or move in space. Like there's one that takes hydrogen atoms.
Exactly. Yeah, I was about to talk about.
Right on. Did you guys find out how cold it is there? Sorry, just don't want to lose that point. How cold is it? At 250. Like, what's the temperature up there?
Let me.
My computer just froze. So I was trying to look it up. Let's see.
Let's see. The International Space Station, without thermal controls, the temperature of the orbiting space station's sun-facing side would soar to 250 degrees Fahrenheit, 121 degrees Celsius, while thermometers on the dark side would plunge to minus 250 degrees. There's nothing to absorb heat in space, right?
It's radiation.
Yeah, our atmosphere is what keeps heat in the planet, right? If we had no CO2 in our atmosphere, heat from the sun would just reflect off the Earth's surface and go back into space. That's why it's important.
So what keeps that vacuum? Like, explain to me how we can have a vacuum of space and then our own atmosphere? Like, how do you go from?
Because our atmosphere is created by a composition of chemicals in the air, like CO2, for example. Like, let's look at Venus and let's look at Earth, okay? Earth has enough CO2 in the atmosphere that it keeps enough heat in, but lets enough heat out that it doesn't overheat the planet. That's the greenhouse effect. If the more CO2 in the air, it creates a greenhouse that heats up the planet. So if you look at Venus, they have a runaway greenhouse effect where it's so flippin' hot that, like, Russia has sent probes that have landed on the surface of Venus. They've been on the surface of Venus for like 6 minutes and taken pictures before it literally melted because it was so hot. So
I'm just trying to get my head around how you can have no vacuum go to a vacuum, because the whole point to a vacuum is it's completely separate and contained. But I can't get it through my head.
Earth is within it, but the planet itself can have its own atmosphere.
Yeah, the planets have atmospheres, yeah.
Which can entrap what we see here, kind of locked, if that makes sense.
And the thing is like, so the gases can't expand forever. Eventually they'll become weak and they won't be able to hold the same composition as they did before. So that's how you see the end of kind of an atmosphere, right? At some point, the gases won't be dense enough to make an impact anymore.
Okay. I don't understand still, but maybe I won't. Anyway. Okay, cool.
So do you guys have any other questions or?
I don't have any.
How old do you guys think the flat Earth is? I'm just curious. Like, from your perspective, it being a flat Earth, how old do you believe it is? Like, would you agree it's probably billions of years old, or would you say it's a younger Earth? I know a lot of people like to kind of quote like scripture of different religious books, kind of saying, well, this religion's saying the Earth is flat, so it has to be flat. I didn't know if that was your motive or not, or if you think it's a flat Earth that's billions of years old, or if it's super young.
I think it'll be really interesting as this plays out and as it goes one way or another, because, I mean, one thing we can all agree on when we're talking about the flat Earth, we're not talking about, space conspiracy or Kennedy getting shot or anything. It's different than all of the typical conspiracies. And it's kind of like, I haven't really come across a topic that gets people so wired on both sides.
I would say it kind of is, in the same sense. Like, the same issue I have with a lot of conspiracies is like the amount of people that would have to be hush about it for it to.
But they really don't, man. Think about it. If you think about it in your own family, like if you have your own family and you run a business and you guys know what's going on, but you just hire people and you tell them to do something, but they don't know what's going on. It's the same thing, man. They're good people. They're just working for you.
But you would have to require essentially every astronaut, all the engineers that worked on it, to take this into consideration.
But why would they? I saw a video of the guy who
because their numbers are based on the fact that the Earth is round.
No, but I'm just saying, I saw a video of the guy who actually built, the cool compartment on the lander that held the RV. So there was a video about the guy who actually manufactured it, and he is now a woodworker in wherever, Kansas or somewhere, not Kansas, but somewhere in the U.S. And he didn't even know if his final design actually went to space. He got a plaque and everything, but he didn't know what happened, and he's the one that designed the thing.
I think that's a false comparison, because what we're looking at is not just astronauts and engineers and physicists and astronomers and a wide array of people from a lot of different fields of science and math. They do this based off a few notions, such as gravity, such as the Earth being round and spinning the orbit. So for that to be wrong and all this to be wrong, that would imply that.
But it isn't wrong. The math does work. That's the problem. Like, what? That's what I'm saying.
If it
like
works,
things.
Then where's your argument for a flat Earth?
But the math can work for anything. The math, like Eratosthenes or whatever.
Would you say 2 + 2 = 4 every time, or is there another way to get a different answer?
So the guy who did the stick test and discovered that the guy that did that worked works on a flat Earth model too, which is funny because that's the
no,
proof
like
that
what I'm saying is like, for example, when we found Neptune, we used it based off of gravity and kind of the idea that we revolve around the Earth. A lot of people have done it. A lot of governments. It's not just the United States government. It's many governments. China, the Soviet Union, France, a whole bunch of other ones.
So, okay.
But
what about the existence of time zones, the center of gravity, images from space? I know you don't like agree with images in space, but like plane rides, other planets. Like, it's just, there's a lot of evidence that
a lot of people would have to be in on it. The snipers would have to be in on it.
There would have to be
I don't agree with. I still don't agree with that. But I agree to disagree. You can have that, and I can have mine. Yeah.
Well, I think we should end this so that people that are actually watching it after the recording can get through the whole thing. But yeah, good discussion, guys. I know we got a little out of hand there at the beginning, but it's fine. We ended up very good at the end of it. But anyway, that is it for the show today, ladies and gentlemen. If you enjoyed, make sure you like and share, and don't forget to subscribe. And let's let our guests here kind of give a one last farewell and where you can find them if you want to learn more about the flat Earth and everything like that. So go ahead and
take it away, James.
Right on. Well, you can find us at the Iron Realm Twitter page at ironrealmmedia.com or our YouTube channel, Iron Realm Media. We also host a weekly podcast, and that's every Friday at 11 o'clock GMT. And you guys are more than welcome to meet our crew and come on and have a similar discussion. In fact, I would love it.
Yeah, I'd be totally down to do that. Yeah. All right. Well, we'll talk to you guys later. We're going to end the recording. You guys can hold off after the ending. We can talk a little bit. But anyway, we're ending it now.